Good evening, all of you. Am I audible to you all? Am I audible to all of you? Is there any interruption in sound?
Yes, yes, sir.
Echo? Echo issue. Good evening, all of you. I'm Desh Deepak, Assistant Professor at Satya Sai University of Technology and Medical Sciences. Today is a very great day for all of us, as this university is going to organize a first of its kind School of Engineering is going to start its first FDP program, that is Green Hydrogen and Future of Renewable Energy System. We would like to thanks to our Honorable Vice Chancellor Sir Dr. Mukesh Tiwari Sir. Under his guidance, under his leadership, under his continuous motivation to all the faculty members, through which we got a motivation, and he's just like a whole North Star who always tried to motivate us and always helping us for developing and organizing this kind of faculty development program. Now, today we have a guest, Dr. Rajan Vashne. He has a vast experience of 35 years of experience, and he would take a session of green hydrogen with along with all the participants joining in this faculty development program. Before it started, I would like to invite our university's senior most person officials, Dr. Professor Sanjay Rathore sir, who would like to highlight some important aspect and dimension of our university, that how this university is going to be Central India's most prominent and emerging university in this country. Now over to Dr. Sanjay Rathore sir. Sir, आपका बहुत बहुत स्वागत है सर.
Good evening, all the honorable experts, dignitaries, faculty members, and researchers. Myself, Dr. Sanjay Rathore, working as a professor since 30 years. It is really a great pleasure for me to be with you on this FDP inaugural program on a very important issue of green hydrogen, renewable source of energy. In the present scenario, world is facing this energy problem. It is a crucial topic and very important topic for the world to seek and explore this source of energy. It will be beneficial for the world society. First of all, I want to explain about my university, esteemed university at Sehore, Sri Satya Sai University of Technology and Medical Sciences. It is working since 2013, and we are committed to provide good education for the weaker section and for the young potential to work for the country. Our faculty members are also seeking such motive. I think it is the third stage of FDP that we are conducting. So I do hope that we will proceed in this program for the to develop or to generate new energy. बंद कर दिए. To generate energy in the youngsters, to develop some new ideas on for this crucial topic like green hydrogen. It is a renewable source of energy. My all the best wishes on behalf of university and my honorable vice chancellor for this FDP program. Thank you.
Thank you so much, sir. Here you are listening the professor senior most official from the university side, that is Dr. Sanjay Rathore, sir. Thank you so much, sir, for sharing and best wishing for this faculty development program. Today is a great day for all of us because this is a golden opportunity to all the faculty members and all the participants joining in this program, which is topic that is green hydrogen and future of renewable energy system. This university is pioneering institute where we are conducting 11 core branches of engineering. Apart from that, we are recently brought up a new MBBS college in our university where we are shaping the new doctors for the nations. Recently, now I would like to thank, I'm also thankful to Dr. Sachin Baraskar sir, who has a vast experience of 17 plus research papers along with Dr. Mr. Manoj Gandwane sir, who has a vast experience of 14 plus research papers, who was the main coordinator and co-coordinator of this faculty development program. And with this kind support and with this kind helping nature and continuous support, this faculty development program is going to organize in our university. Now we would like to invite the research director of this university, who is Mr. Dr. Mohit Gangwar sir, who has a vast experience of 70 plus research paper, lots of publications, and he has Springers and various Scopus papers along with this talent. Dr. Mohit Gangwar sir also encourages the continuous research and also the continuous efforts for developing the new things for the new nations. Now, I would like to invite Dr. Mohit Gangwar sir. Welcome you, sir. Now, we would over to you, sir. Thanks coming.
Thank you, Deshdeepak ji. Good evening to all of you. I am Dr. Mohit Gangwar, Director Research, Shri Satya Sai University of Technology and Medical Science, Sehore. On behalf of our university and our Honorable Vice Chancellor, Sir, Dr. Mukesh Tiwari, Sir, our Controller of Examination, Sir, Dr. Sanjay Rathore, Sir, our Registrar, Sir, Dr. Hemant Sharma, Sir, on behalf of all these, I would like to welcome all the dignitaries, all the speakers, all the faculties, all the researcher for joining the inauguration session of this FDP. So basically, this FDP is in offline mode. So basically, due to offline mode, we can connect to people, those who are very far away from us. Like we can connect people from Chennai, from Bangalore, and all these areas. So in that sense, we will get the multiple participants flavor and their also their view to discuss in this particular FDP. I would like to Dr. Ashok ji, today's speaker, and Dr. Rajan Vashne sir, he is also the today's speaker. So both will give you the deep knowledge about the green hydrogen energy, and definitely you will able to get the so much knowledge in these areas. Basically, I just wanted to tell you in this FDP we have received around approximately 200 registration around the country, and we have invited 11 Indian speaker and 2 foreign speaker from Nepal and from China for delivering their expert talk in expert session in this FDP. So definitely, it's a 6 day long FDP will enhance your knowledge, and other than knowledge, you definitely will get some sort of research flavor. So you can write good research paper in this area, as well as you can also generate some good projects and some sort of mechanical equipment machines, those who can actually make some useful things from the green hydrogen energy. So basically, we all are aware that fossil fuel and not fossil fuel in our world. Basically, non-fossil fossil fuel is a limited, so we have to protect the environment from because we don't want to consume all the fossil fuel, and it is also generate some sort of pollution in our environment like greenhouse gases. You can understand about these. So basically, this particular FDP will focus on how you can generate energy, but rather than generating energy, how you can generate clean energy. Because this is the right now fundamental challenges. We are generating energy. Even some sort of means in this green hydrogen energy, we will we will the bifurcate distilize the hydrogen and other thing through also through also non-fossil fuels. So this is the main idea behind this FDP, and definitely in our group of universities, we have also already established a very good renewable plant in our RKDF campus. So anytime if participant wanted to come in Bhopal, definitely we will arrange your visit in RKDF renewable energy plant. So I again I would like to welcome all the participants and both of our speaker today. So best of luck from my side. And in the last, I would like to congratulate our coordinator also, Dr. Sachin Bharaskar and Dr. Mr. Gandwane sir, and our today speaker Desh Deepak also. Thank you very much. Thank you.
Thank you so much, sir. Thank you so much, sir. Here you are listening the research director of Sri Satya University of Technology and Medical Sciences here. Basically, now you all getting an idea that in this faculty development program, basically you all are going to know that how green hydrogen energy is shaping the world, because the fossil fuels, carbons, and continuous use of petroleum and dependency on coal can making these resources very limited. Now, these kinds of energy and these kind of initiative which was took by coordinator Dr. Sachin Baraskar sir, who has coming up with the global trends and emerging trend of the world, where the topic is green hydrogen and the future of renewable energy systems. Here you can understand and got a lot of experience through the valuable insight of the valuable and very keen vast experience of the researchers and the resource person who will join this meeting. Today, in the first session, the first speaker of this faculty development program is Dr. Rajan Vashne sir. About Dr. Rajan Vashne sir, he has over 35 years of experience in the energy sector. He has taken several initiatives in circular economy, including cost-effective, low-carbon hydrogen and waste to wealth. He is a B from DIT and MTech from IIT Delhi and MBA from New Delhi. He has a certification include from Harvard Management Mentor, certification in a carbon market, hydrogen economy, and the energy market. He is a member of several expert committees like CST committee by the Niti Aayog, Power Sector Reforms Committee, also by the Niti Aayog, High Powered Committee for the replacement of a sand by bottom ash in road infra by MOT. He spearhead efforts for the September 2020 notification for HCNG as a permitted fuel in Indian Motor Vehicle Act and safety standard for FCEVs. His interest area including concentrated solar technologies, nanomaterials, wastewater treatment, and CO2 capture and utilization, hydrogen economy, waste to biofuel, and including hydrogen and its derivative. He is a governing council member of the Skill Council for Green Jobs, an initiative of the Government of India promoted by Ministry of New and Renewable Energy. He is also a certified trainer for the hydrogen and renewable energy. His several papers on hydrogen economy have been published and also as a chapter on hydrogen production from biomass in book published by the Springers, Singapore under the Climate Action and the Hydrogen Economy series. This book was also launched by Mr. Melly and Ellen Stanner, HE Ambassador Royal Norwegian Embassy as a chief guest. He is passionate about the environment and sustainability, and also he has been keynote speaker at many national and international conferences. This is the short biodata of Mr. Dr. Rajan Vashne sir, who has a vast experience, and I hope so. This experience has to be shared with all the participants, and now I can understand that after this FTP program, would all understand and you would all understand and getting a new initiative and new thoughts and ideas apart from this FDP program. Now, at now, I would like to thank Mr. Coordinator Sachin Baraskar sir, who has been beautifully designed and beautifully narrated this faculty development program on green hydrogen initiative. He has a lot of experience, 17 plus research paper, and he is the most HOD of the mechanical engineering department in Sri Satya Sai University of Technology and Medical Sciences. Sri Sachin Baraskar sir has a lot of experience and is keen researcher. Recently, he has developed a solar powered car which got a second prize in the MPCST Council, where they won the solar powered car developed by him under his guidance. Lots of he is also a mentor of different kinds of students who are keen development in different researchers and the research papers also for the utilization for the nation building. Apart from Dr. Sachin Baraskar sir, Mr. Manoj Gandwane sir is the chief mentor for the chemical process, and under his guidance, lots of renewable energy process and systems has been initiated and installed in our university. Anybody can visit in our university because this is Central India's and MP's one of its kind of university where the every child is special and also where talents meets the opportunity. And apart from this, under his Manoj Kanwanesa, he has a 40 plus research papers. Under his guidance, lots of students get placed in various MNCs and alumni of uh, different across the global world. Now, I would like to invite Dr. Rajan Vashnesar. He has been joining shortly along with this meeting, and I hope so. With the vast 35 year of experience, you all will get a lot of experience from his thoughts, from his ideas, and also from his the research experience he gained from his continuous efforts in the research in hydrogen energy. Recently, you all will know that in Germany, hydrogen energy and hydrogen powered train has been developed. Now, we would like to also we would also like to get these kind of knowledge and initiative from in our respective university, where you will also share their thoughts and ideas to all the students. And the second session speaker of today's session is Dr. Ashok G. Matani sir. And about Dr. G. Mathani sir, he has been retired mechanical engineering professor from uh, Government College of Engineering, Jalgaon, Maharashtra, and he has a total 33 years of experience, about of industry experience of 6.5 years. He has a manufacturing supervisor in Srinivas Latha and Company Amravati. Also, he has a junior engineer generation in MSME Mumbai. About his academic experience, he has a lot of experience in government services. He has a lot of area of expertise in energy and industrial and engineering, environment, AI, and IoT applications management and NEP. Dr. Ashok Matani sir has a lots of 12 best paper awarded in a conference, seminars in IITs, NITs, AICT approved institute. So I hope so. We will also got a experience from Ashok Ji Matani sir in a second session, where he will share their valuable thoughts, their ideas to all the participants joining in this faculty development program. He has a 3 PhD scholar awarded PhD degree from Sant Gaji Baba Amravati University, and also have publication in journal that is 100. He has 100 paper presented in IITs, IIM, NITs, and CGFIs, organized in institute approved by AICT. Also, he has a keynote speaker in various institute and various management institute, and a lot of conference experience that is about 60. And he has a lot of he has also this was such a very nice data figure I have got it, that they has a 160 plus X faculty development program, and also a STTP expert lecture delivered by Mr. Ashok, Dr. Ashok G. Matani sir. So these are the two keynote speakers for the today's session. In first session we got a Dr. Rajan Vashne sir, and in the second session we got Dr. Ashok G. Matani. This is a brief idea of the today's session of this faculty development program. Soon, in a very short period of time, Mr. Rajan Vashnesar has to be joined this meeting along with this. Now, I would like to highlight some important aspect that this is a 6 days faculty development program, has been organized by School of Mechanical Engineering, and we would also like to thankful to the Dean School of Engineering, Dr. Rajan Singh Kushwaha sir. Under his guidance, his continuous effort, and under his continuous motivation, we also got to deliver something new, something innovative, and something researchful, which will be beneficial for the society. And we would also at last thankful to Dr. Mukesh Tiwari sir. He is the chief mentor, chief guider, and chief anchor for the whole of this ship which is he is guiding like a north star, as I told you earlier. Under his guidance, not only a single staff but also the each faculty get a motivation, uh, continuous support. Under his guidance, we also doing some researches and new projects and new ideas has to be implemented continuously in this university. Now, very soon we would like to invite Dr. Rajan Vashne sir. Soon he will join into this meeting. Once again, I would like to welcome you all the participants from the different university from different states across the India, and also from the foreign international where they can join in this faculty development program in this SSS UTMS Sehore. Now, Mr. Rajan Vashne has to be coming up in this Zoom meeting app, and very soon he will get to join along with this faculty development program. And once again, I'm thankful to all the participants who's registered and joining in this Zoom virtual faculty development program, because this is a great initiative where we can exchange our ideas, our thoughts, and various initiative and various research thinking process which has to be initiative for the nation building and for the nations, for the society benefit. कर दो सर गाड़ी share से। बना दिया। Hold कर। We welcome you, Dr. Rajan Vashne, sir. Now, the mic and this meeting of this faculty development program is over to you, sir. Now, I would like to request you, and on the behalf of Sri Satya Sai University of Technology and Medical Sciences, Sehore, we would all welcome you in this Zoom meeting app, where we are very excited and keen excited to learn a lot from your experience. Sir, we once again welcome you all. Kindly proceed, sir.
Yeah. Good evening, everyone. Thank you for having me here. The I'm really interested and keen to contribute to the FDP program. That is why you have selected me as a keynote speaker. And uh, energy transition and green hydrogen, the topic which has been given to me, is very relevant actually, because if we have to have cleaner energy sources in our usage, uh, we have to have importance of green hydrogen in the context because it touches many areas. So I'll just connect my presentation and all within 2-3 minutes. Okay.
Hello.
Hello. Is my voice clear?
Yes, sir. Voice clear, sir.
Yes,
Okay.
sir, you are audible to us, sir.
Okay, good. I'm opening the presentation, just a minute. Is the presentation visible?
Yes, sir.
Yes, sir.
Okay, great. So,
It is visible, sir.
good. So, climate change is occurring very fast, and we have seen so many changes in weather patterns, unseasonal snowfall, unseasonal rains, droughts, excessive floods, and so many other things. And this is all due to, this has been linked to GHG effect, greenhouse gas emissions, which is making our planet greenhouse, and heat liberation is happening very fast with respect to like temperature rise, which is we have been seeing that previously the target was 1.5 degree temperature rise with respect to this century, and now it is very difficult. It is being treated as very difficult. So now the new target is 2 degree. But again, if we do as it is the way we are following, the things will go out of hand and will make the planet even survival will be very difficult, because these weather patterns and other things change the uh, crops and other patterns also. So we have to have food, we have to have energy to have ourselves comfortable. So in any uh, condition, India has so many polluted cities, so we have to cut down the pollution also. It is affecting our health, productivity, and expenses on health and all. Is the slide changing? Yeah. Are we seeing change in slides?
Yes, it is changing, sir.
Okay,
Yes,
good.
sir.
So climate change is a $11 trillion opportunity for India. Otherwise, it is a great risk. This is a Deloitte analysis, because the pollution is costing very high and the temperature rise, which is affecting so many people, like uh, heating, cooling needs, like cooling needs are increasing. For that, we have to have peak energy requirement, more ACs, and again, these are emitting greenhouse gases and heat to the atmosphere. So hydrogen, in what form we should have? We have seen that electrolysis based hydrogen is being treated as green hydrogen, but now in Indian context, the definition of green hydrogen here has been where we have included biomass to hydrogen also, and the non biogenic CO2 emission is being counted in that our definition, and this is 2 kg CO2 equivalent emission per kg of hydrogen. If it is up to that, it is treated as green. But if we simply convert all electricity to renewable electricity, it may not help, because energy is not only electricity, it is in heating, industrial cooling, and buildings and all. So what happens is, just a second. Yeah. So, energy requirement, out of that total energy requirement, only 18% is catered by electricity. So, we have to have lot many things to be done. Only renewable electricity, that too through PV or wind, which is intermittent, and at times it is most of the times it is not available uh, and fluctuating. So we have to have firm sources of power, as well as energy requirement has to be um, done, and energy storage is also to be there, so that for the base load and other non-solar or non-windy times also, we can have electricity as well as other energy sources. So hydrogen is so much vital that it can serve many needs. Like it can be a feedstock also, it can be a energy source also, it can help in storage also. Somehow I'm not able to change the slide. Just a second. I think I'll join again, just log out once. It is not allowing me to change. Just a second. Is the screen visible now?
Yes, sir, it is visible, sir.
Okay, now what is the slide which is there? Title is urgency. Can you just confirm this slide?
Yes, urgency.
Okay, okay, good. So now it is very urgently required to address the GHG emission or climate change problem. And for India, we have actually electrolysis is very common and everybody has been discussing. I'll not touch that in detail. what I am going to discuss is waste to hydrogen and newer technologies, not newer, but better technologies for hydrogen production so that it can be most economical, cost effective, and also addresses pollution and other aspects. In electrochemical or through electrolysis, the hydrogen requires first renewable energy, and that too around 50 to 60 units of electricity per kg of hydrogen produced, along with around 20 liters of water, 9 liters of distilled water out of that. So a lot of energy is required, and hydrogen 1 kg is equivalent to roughly 33 kilowatt hour of energy. So if we use waste and other materials, we can produce hydrogen in much lesser real energy. I mean, if we have to use heat, equivalent amount of heat and equivalent amount of electricity, like if we want 50 units of electricity, we have to have about 150 to 200 heat to convert that into electricity. So in thermochemical methods, we can directly use heat and produce hydrogen that we'll see in detail. And waste to hydrogen so immediately reduces our GHG emission, and world has 2 billion tons of waste which can be converted to various forms of biofuels including hydrogen. India also has a lot of waste, and what I told 2 billion tons, that is MSW, municipal solid waste. But there are lot many other wastes like agro waste, animal dung, sludge, poultry waste. Agroforestry also is being done, napier grass, cane sugar, and other varieties are being grown to produce biofuels, including hydrogen and other derivatives. And hydrogen, I said, is an important part of the puzzle to control greenhouse gas emission and to have a just energy transition. So hydrogen is used as a feedstock. It is used for energy. It is used in fertilizer, steel, chemicals, oil refining. Most of the hydrogen today, 90% of the hydrogen used in India is being used in refining and fertilizer industry. And we can control our imports also. Even for fertilizer, ammonia is imported, and for various usage, our like transport, heat, LNG, petroleum, everything is a lot of it is imported. So we can save these imports, improve our fiscal balance, make country energy independent if we can utilize our waste properly. And waste, especially the wet waste and agro waste, if we leave them as it is, they decompose and produce methane. And methane is 84 times more potent GHG gas than CO2. So if we can use that methane instead of importing natural gas, we can save a lot. And also the pollution and deterioration in our soil, water, and atmosphere conditions. Moreover, for energy storage, we can use hydrogen and then use this to various usage, including feedstock and other things, and transport, etc., or in blending as and when required. So H2 is a versatile energy carrier interconnecting various sectors. And we have seen in Tokyo Olympics and China Water Olympics and other games also that hydrogen villages totally dependent on hydrogen have been able to serve people. So if we can reimagine waste and produce H2, it is a greener solution. It can help in GHG reduction. It can give us energy security, cleaner air, water, and soil. And moreover, it can address our waste management, so many landfill sites and all. And it cuts down imports. So this is a solution which fits our requirements. Many companies across the world are into it. Even Indian companies also, IPR has developed plasma gasification, Bark has developed, many Indian companies have developed and are developing technologies. This is one example of H2 Industries, which is developing big plants for waste to hydrogen in Egypt and Oman. And then in India, this is so high tech, which has tied up with the TKIL, Tyson Group Green Energy branch, and they are doing it through concentrated solar and electrolysis mixture. And it is also very cost effective. This is a dish which is I'll come to that, how firm energy can be uh, renewable energy can be given 24 hours 24 by 7 and 365 days a year with the thermal storage. So this is part of that only. They are using parabolic dish and producing hydrogen through electrolysis. This is the bigger photo of that. And basically, this is a Swiss-based company, although promoted by an Indian only, but established there, and now they are bringing the solutions here. They have tied up with Telangana government also recently for green hydrogen production, cost-effective green hydrogen production. This is called concentrated solar power, and we can have storage in various forms like particle storage, solar surface storage, and most prevalent is molten salt thermal storage. So during the day, we reflect sunlight and concentrate it on a receiver, and then the heat transfer fluid, cold pipe in shown in blue color, it takes heat from the receiver, and the heat gets stored in another tank, and whenever it is required through heat exchanger or steam generator, the water is converted to steam, and the turbine rolls and produces connected with generator, it produces electricity. Just it replaces coal or gas. Directly it can use the solar heat. And there are several techniques: parabolic trough system, power tower system, which is shown there, linear Fresnel, parabolic dish, beam down, and other technologies are also developing, and some are this. And we use extra mirrors. Extra heat can be stored in molten salt, that heat transfer fluid. And there are at least 150 plants across the world working on this principle and this technology. Even in India, also, 4 plants are working on this. I'm also member of that task force which Niti Aayog has put for CSP and CST technologies. This is a meeting with the ex-minister. Then it can be very cost effective also, even for power generation and heating and cooling, all needs. And molten salt storage is at present the major storage, energy storage medium across the world, like the first bar shows. And the technology has been developing in last 10 years immensely, when China has come into it very fast, and the cost is reducing around 80%, it has reduced. And then this heat can be used for refrigeration also through absorption cooling system, and desiccant cooling. So it can reduce the need for electricity for air conditioners. If we can have district heating, district cooling, and industrial heat directly, we can supply instead of first uh, wasting energy in converting heat to electricity and then use that for heating. So this technology can even reach up to 3000 degrees centigrade temperature also. This is in US. They have been running this system for 3000 degrees centigrade for last 10 years. And this clean heat can help in hydrogen production through various cycles also, in thermochemical splitting of water also. This is a cerium oxide cycle, and the other one is copper chloride cycle. Even copper chloride cycle has been developed in India also, patented also. And many countries, various startups have developed. Sun Hydrogen is having hydrogen panels. Then China has a 200 tons per year plant recently inaugurated on 12th December for thermochemical splitting, photocatalytic splitting of water. And similarly, there are companies like New Hydrogen who have developed a technique of using heat only, no electricity. They have bypassed the electrolyzer. So it is more energy efficient. Similarly, many new technologies are developing in this area for producing hydrogen through uh, using heat or artificial photosynthesis, and similarly through bio microorganisms. And this thing has given rise to pyrometallurgy. Even aluminium can be extracted from alumina through heat only, no electrolysis required. And even the methane, which gets developed through deterioration of wet waste, through heat, there is a pyrolysis reactor which is called liquid metal bubble column reactor. Here, through solar heat and thermal energy stored, we can have 24 hours conversion of methane to hydrogen and solid carbon. So no energy or cost is required for carbon capture. But that even carbon can be converted to graphene and so many other important things which are derived from fossil sources, and they are much more costly also. Like graphene sells at say 1 lakh rupees per kg, a good quality, and even the industrial powder graphene can be at 10,000 rupees per kg. So if we are able to get methane which is getting released from the waste, we capture that and convert it into hydrogen and value added products, so we can have very cost effective hydrogen also. Similarly, CSP has been there for new process for ammonia production is also happening. Ammonia is like transporting H2 is costly, but we can transport ammonia and then convert it into hydrogen whenever required. So India is at a very nice turning point, pivotal point, where lot of our growth is to happen in next years, and let's say 10 times growth is to happen in next few years, and our base is like we don't have the sunk cost. We can invest in new technologies which are environment friendly, and they will become cheaper because we have a lot of scale ahead of us. These are some of the developments, and this is some new trends in CSP, and now the supercritical CO2 cycle is also developing, which is having more than 50% efficiency for heat to electricity conversion. China has started one plant, and this is just like you can remove the existing coal-fired boiler and make a heat exchanger, but it requires high DNI areas. So these are available in plenty. One research is out recently, and they show that there is more than 500 gigawatt 24 by 7 power that can be generated through CSP and thermal storage, and it is like more greener than PV, and everything can be made in India. One plant, Godavari Power, is in Rajasthan, and it is working since last more than 10 years. And but it doesn't have storage because at that time storage need was not felt, and PV was also not there that much. PV was getting introduced only. This is about 2012-13 in Jawaharlal Nehru solar mission, where both the technologies, both the tenders were out for CSP without storage and PV also. PV was at that time 17 rupees per unit or so, and CSP, this Godavari plant, won at 12 rupees per unit, and it is working very fine even now. And it has a life, CSP has a life of more than 30, 40 years. Even plants are working since last 50 years also. Glass doesn't deteriorate, it doesn't corrode. And if it has to be recycled, even it has a salvage value, because glass is a super cool liquid. It can be remelted and put into different forms. Molten salt is also, it is potassium nitrate and sodium nitrate mixture. So when it has to be discarded, it can be converted to fertilizers. And newer techniques can help us in doing this. Now, what commonly is being used is biomass or organic waste or sewage sludge and other droppings, and what I had shown, agro waste and the organic fraction of MSW. It can either be gasified or pyrolysis can be done, and directly it can be converted to green hydrogen after purification. IOC and IISC have been working on these. Sentient Labs, KPIT Research has worked on it. Institute of Plasma Research, I had told initially also. So many companies are working on it. And this is a plant in Gift City, small plant up to syngas, and then syngas can be purified to make hydrogen. Now, the other technique is, instead of gasification or pyrolysis, we can have anaerobic digestion of wet waste. And in gasification, we can have, we don't need even segregation, and we can directly produce syngas, and then syngas can be converted to hydrogen or to any other chemicals, because that is a base for many organics. Now, in this second method, we can have the wet waste converted to biomethane, first biogas, then biogas can be directly converted to syngas, or first upgraded to biomethane by removing CO2, and then biomethane can be either converted through steam methane reforming process to hydrogen, or through methane pyrolysis, which I had indicated initially. The advantage is we can cut down the transport cost also of hydrogen, because we can produce hydrogen from biomethane anywhere we require near the point of use. Some companies like Biotech, Highgear, they're supplying small SMRs also, steam methane reformings also, for this. This is one sketch of Biotech. Some SMRs, Chinese companies are also supplying and very cost effective. This is one small nanosol which has made a specification and cost estimate. And waste to biomethane is much more economical. And then biomethane to hydrogen can be done through methane pyrolysis or steam methane reforming, or first biogas can be directly converted to hydrogen through dry methane reforming. Some companies are doing it, and like solid carbon which we get after methane splitting can be in the form of carbon black or graphite or carbon nanofibers, and biochar can also be produced, and all this has tremendous value. And this is one paganism innovation. They have developed one Rudra reactor for methane pyrolysis. And this is installed at Banas Dairy in Gujarat. This is a Monolith USA company which is developed this plasma methane pyrolysis process. Then this Hazer Australia, they are having a uh, process for methane pyrolysis which uses FeO, and they are tying up with the steel plants to cater to their hydrogen requirement and help in greening the steel. This Pure Hydrogen Australia, they are using methane pyrolysis with electricity, and it requires only 7 units of electricity per kg of hydrogen in this process. Similarly, C0 USA, they have a molten salt methane pyrolysis process, and so many other companies are having this similar things for methane splitting. This SEID has having a cold spark, and they are using this cold methane pyrolysis. It uses 10 kilowatt hours, 10 units of electricity per kg of hydrogen produced. And the major advantage is it is not producing any CO2, because solid carbon is getting collected at the end. Levidian, this is a company which is having a reactor called Loop, LOOP. They produce graphene and hydrogen, and graphene sells at much higher value. So we can reduce the cost of hydrogen, so it becomes cost effective. Then biohydrogen production through dark fermentation, microbial electrolysis, biophotolysis, etc. These are the various methods which are being developed. So this can microbes are the most efficient processes. So we can have cost-effective hydrogen through them. If we see, there are many advantages also. Anaerobic microorganisms convert organic matter into hydrogen in the absence of light. The process uses anaerobic bacteria such as Clostridium, Enterobacterium. This method is it can operate continuously as no light is required in dark fermentation, and it can use lot many varieties of waste materials. Then there is direct biophotolysis. Here, microorganisms like green algae and cyanobacteria use solar energy to split water into oxygen and hydrogen in one step. Then indirect biophotolysis is also there, where steps of photosynthesis and hydrogen production, and first photosynthesis is done for converting carbon dioxide into carbohydrates, and then fermentation is done to produce hydrogen. And it can be done in the absence of light, like dark fermentation. And then advantages are it can use abundant sources, water, solar energy, organic waste, can be performed at ambient temperature and pressure, reducing energy costs. And we have advantages here with respect to electrolysis hydrogen, advantages of hydrogen from waste with respect to electrolysis hydrogen. Because in hydrogen produced by electrolysis, the cost is around 250 rupees or 300 rupees per kg. Now, Platts rate has also come up for India also, and the latest rate was around 230 rupees per kg, because it requires around 50 to 60 units of electricity for 1 kg of hydrogen. And if we consider just the electricity cost itself, even if it is 3 4 rupees, the cost of electricity itself becomes 16 to 4 240 rupees. And then the other capex has to be depreciated and paid back through EMI or whatever. And then storage cost, transport cost, so many other costs are there. And moreover, a lot of land is required. For 1 megawatt of RE, you require around 25-acre land, because if PV is installed in, say, 4 acre, 1 megawatt, but it is like it has a CUF of only 15% or 16%, 17%. So you have to have six parallel fields for producing this for 1 megawatt, because it will produce only that much energy, and then it has to be like 1 megawatt into 24. So 24 megawatt hour energy production requires around 20 acres, and then it has to be firmed up. It has to be stored in, say, batteries, or through thermal storage. First, this electricity to heat through heaters or some other way, or that electricity can be used to produce hydrogen. That hydrogen can be stored for a longer duration, because battery helps you in storing, say, 4 hours, 6 hours at the most, normally 1 to 2 hours. So but you have to have 24 by 7 electricity to optimize the cost of electrolyzer. Otherwise, you will have to have 6 electrolyzers during the day, and then storage of hydrogen has to be done, and which is a costly process. And moreover, a lot of land will be required, and then transportation cost will be there, and it requires a lot of water also, and materials like nickel, platinum, iridium, zirconium, yttrium, etc. And all these things are not available in India, so again, import dependent, and water scarcity it will cause. So if we go for waste to hydrogen, we can have much more economical hydrogen, as well as it can control our pollution, and also give us immense health benefits, and put to use presently, which is the material which is generating greenhouse gas emission, which is 84 times more potent, the methane. Then it can cut down our imports if we use hydrogen for various applications. Already hydrogen train is getting developed. Several companies have deployed hydrogen buses. Even in Ladakh also, there is 5 buses deployed. Then in military areas like Kargil and other, Chushul, microgrid for giving heat and electricity and cooking needs. Microgrid through hydrogen has been developed, and lot many benefits it accrues. Like previously, they had to transport diesel or kerosene through helicopters to these high reach areas, high altitude areas, and now they can do it like this through hydrogen cost effectively, as well as import is also reduced. And then we can convert even waste to other products like ethanol, methanol, and then we can convert to hydrogen as and when required. And this is a comparison where ethanol is can be easily transported and then converted to hydrogen wherever required. This is a Golu H2 process, which is developed by SBI Bioenergy in Canada, and it is also very cost effective and avoids transportation of hydrogen, as ethanol is standard as a standard method is being transported. Then this microbial electrolysis for hydrogen from waste is getting developed. This is a very cutting edge technology and it has many advantages. It can use wastewaters, fermentable, non-fermentable organic materials also, and through the use of bacteria. And it can be very cost effective also. And it can even use plastics also, waste plastics also. This is called microbial electrochemical cells. The advantage is it can produce hydrogen along with ethylene glycol and terephthalate. These are all various raw materials for base materials for producing plastics and petroleum products. And this disodium terephthalate sells at 50,000 rupees per kg. So if we can produce value-added products from waste along with hydrogen, we can have very cost-effective hydrogen. And depending on the material which is used to produce hydrogen, we can have carbon credits also, and the processes and the applications which we use that hydrogen. One other point is the critical materials which are required for electrolysis, which are not available in India, and mostly China has controlled 90% of the supply, either refining or the supply. So geopolitical situations also require that India should shift to green hydrogen. And it is clear that H2 has minimal imported material requirements, so least dependence on imports for India. Even for electrolyzers and fuel cells, we are importing so many things, and they require some materials which are rare earths or platinum and other things. Even for PV based electricity generation, we are importing so many things from the ingots, like China is supplying to whole world basically. And even if we see electric vehicles, they have also, we have seen in the past when China controlled the microprocessor things. So electric vehicles also require a lot of such elements. If we run our transport on hydrogen, and that too from locally produced hydrogen, from locally produced materials, we can control the cost, imports, and our energy dependence also. We become energy independent. And 2047, if we have to have energy independence, we should focus on hydrogen, and that too from cost effective hydrogen from waste, and replacing several other materials like graphene, graphite, carbon black, which we presently use, and they are coming from fossil sources. So all this can reduce our greenhouse gas emissions, and even H2 can be blended, which I actually got the notification done. I spearheaded this with the North, and it involved so many departments in 2020. So the experiment was, this is about our hydrogen Toyota Mirai, which Mr. Nitin Gadkari and Minister of State are also driving. And then HCNG buses were run in DTC, under DTC from 1st October 2020, when this notification was done in end September 20. And there were a lot of benefits, like only slightly cost increase was there, but 5% CNG, 5% hydrogen was mixed in CNG, and a lot of fuel saving and pollution control was there. So we can have H2 blending in even cooking also. Some townships are already, some agencies are also supplying blended hydrogen in CNG for PNG and CNG. Then we can have repowering of coal plants using hydrogen. Recently, one plant, fuel cell based plant using hydrogen has been inaugurated in Indonesia. It uses GH2 fuel cell system. Basically, fuel cell is from Toyota. So it can have clean energy, noiseless energy, no ash, no coal transport involved, no mining of coal, daily supply of coal. So cleaner power. And PV has an embedded carbon of 50 grams per unit of electricity, roughly. And CSP has less than 10 gram, depending on which technology we are using. And hydrogen also has even negative carbon if we make it from waste. And say if we are using replacing fossil carbon from the carbon which we can generate from, say, biomethane. And moreover, the applications are also cleaner. Uh, so this is like something which we should explore very fast in India to become energy independent. Presently, most of the say last 2 years, if we see, India's H2 consumption has been 6.5 million tons per year, and it is mainly gray H2, which is being produced from natural gas through steam methane reforming. The disadvantages: first, the natural gas is imported, then we use a lot of energy in converting it to hydrogen, and then for 1 kg of hydrogen produced, 9 to 10 kg of CO2 gets produced. But if we use it through other methods which I have described, make it through that greener methods, we can save lot of imports, avoid lot of imports, and also less energy will be required, and no CO2 emission or less CO2 emission will be there if we can get methane splitting through, say, various processes which I have shown, and some other processes are getting developed. Then the advantage is that no energy or cost is required in carbon capture, and value added products can be made. Out of this 6.5 MTPA, fertilizers have been using 3 MTPA, oil refineries having 3 MTPA, and balance industries like glass, chemicals around zero point 0.5 MTPA. So gray hydrogen, LNG imports, urea for fertilizer, natural gas imports. So much imports have been there in say 23, 24 and 24, 25, like around 30 billion import dollars, US dollars. So we can definitely avoid some of the imports and become energy independent, and we can produce hydrogen cost effectively, saving our environment as well as reducing GHG emissions while managing the waste also. So opportunity is huge. what it would mean to replace today's gray hydrogen with green hydrogen. Hydrogen made via SMR consumes roughly 50 kilowatt hour of natural gas equivalent, and typical gas calorific values show that we can reduce our import of roughly 11 billion US dollars if we use our waste and convert hydrogen from biomethane or use the biomethane directly against natural gas. Only thing is we have to uh, follow these techniques and unlock scale for bankable offtakes. Standards and certifications have to be done, infrastructure and cost reductions across value chain, and also huge fertilizer subsidy can be saved if we can use this cheaper hydrogen for producing ammonia and then ammonia into fertilizers. So if we can see that like newer technologies are developing, and if we can have funding of research demonstration and innovation pilots, we can save a lot, because in the initial stage maybe say 10 lakh, 50 lakh, 1 crore is required for making a pilot. But after that, even after say out of 10 pilots, even if say 8 fail, but what we get from those successful two, which if developed commercially, save lot of money and lot of innovations it brings in, ecosystem it develops, and more entrepreneurs come in to create the change. Then carbon intensity should be measured instead of color, and certification should be done. Already we are, our India is doing that. We have come out with the hydrogen definition, and also certification is being, standards have been out. Early to intermediate stage funding should be prioritized. De-risked and long-term finance by banks, institutions, agencies should be there. Like we have seen CSP is a long-term life. Hydrogen electrolyzers are also coming up with increased life. Even PV has a life of more than 25 years. So all these things should come up with de-risked and long-term finance, especially for the new technologies. And insurance for process performance risk coverage should be there. Policies supporting decentralized waste to hydrogen should be there, which can reduce the overall hydrogen cost, as well as transportation and storage needs also, while cutting down the waste landfills and other things. And just like RE, there should be banking of biomethane, and then allowing different points of injection and withdrawal should be permitted. So wherever I can produce biomethane, I can inject in the line, and wherever I need H2, I can draw with respect to the credit which I have or somebody else has bought from me. So this can cut down the hydrogen transportation need, which is very costly, and we have to pressurize it also, and then using at the end we have to decompress it also. So such policies should be encouraged, and the policy should be stable and bold with tax incentives to create uh, initial cost reduction. Then demand creation by target setting for use of green hydrogen across various sectors should be there, and it should be incentivized and subsidies for green hydrogen uptake. Then this carbon market regulation should come up fast, and carbon credits will help in financing the green economy. Then dollar linked contracts for green hydrogen, green NH3, so that export and the foreign capital can come in. They need not do the hedging and all, but all this will increase employment here, processing here, ecosystem here, demand for the various components here. and India can be like producing here and supplying to world. Then PLI incentives, performance linked incentives should be there for steam methane reforming, cleaner using say biomethane and other things, or small SMRs, and for methane splitting technologies and reactors. Then ecosystem development with better coordination for across academia, startups, research, industry, and financial institutions should be encouraged. Researchers should be given credits for industrial participation and supporting ecosystems and ecosystem building events. So, hydrogen from waste has many advantages. Waste can be stored and used wherever required. Major components in this can be manufactured in India. It requires lower capital investment. Decentralized hydrogen production can be there. Rural microgrids, rural electrification can be there. 24 by 7 clean local hydrogen from waste can be produced. It can reduce the stress on grid infra and build better hydrogen ecosystems. Then, with respect to PV and wind, what is happening is we are facing a duck back curve in our energy system. And even after 50% capacity wise, not as electricity units, supply capacity, power generation capacity as out of 500 odd gigawatts, we are having around 250 gigawatt RE based capacity, but still the carbon intensity of the grid is not improved. We have only 17% injection of renewable electricity. So what is happening is we are putting these plants, but they have a CUF of only say 17, 20 or odd percentages, and they even during the day also PV based electricity is getting curtailed. So storage is required, and some of it can be through hydrogen storage also, and moreover CSP and thermal storage can give us firm power. Otherwise, if we are putting coal based electricity also and putting this also putting say 20% from PV and balance 80% from coal based, so the carbon intensity is not getting improved, and this is affecting our various things like our targets and all which we have committed. So there is a lot of scope for converting waste to hydrogen and other biofuels, and cost effectively, while controlling environmental pollution also, which is for India. So hydrogen from waste should be a key driver, meeting the requirements of grid stability, energy storage, transport, and utilization in microgrids, and for various other applications which I have shown that hydrogen is used across the sectors. All SDG goals can be addressed directly or indirectly through this. And this is a multi-decade opportunity. It can integrate RE sustainably, and provide energy across sectors, cleaner environment, avoid methane emissions, and put in waste treatment, clean energy, free prime lands being locked by landfills. It can produce more jobs and lesser migration, because villages can have all the facilities, all the energy through the waste converted to various fuels and electricity through hydrogen. Lesser imports, higher exports, low carbon steel and green ammonia we can produce. This is a planet, people, and prosperity. Triple P advantage, win win for all. So I would stop here, and let us see if some questions are permitted. Are there any questions?
Hello, sir.
Yeah.
Good evening, sir. Sir, in your slides, you have discussed about HHO,
Yeah.
hydroxy gas.
Okay.
And so my question goes with this, like whether the handling of HHO gas is easier as compared to pure hydrogen, or they are like of same hazard.
No, it is very easy to handle. Actually, what happens is, this is, I have shown one example of here. This is Borosil Renewables. They have a glass making furnace. The glass is being made for PV and other things.
Yes.
So that furnace, which is using natural gas, they could use water and renewable electricity to produce HHO and reduce their natural gas consumption by more than 14%. And
So,
the savings uh, could be recouped in 2 years. About the handling, it is nothing. It is like uh, you are producing there itself at the premises, factory premises itself, and supplying to the furnace. So it can save. The major advantage is like it just disturbs the water covalent bonding, and that energy which like water to steam, the volume expansion is huge, and when that thing get converted into water again, and the lot of volume reduction is there, so it is like implosion, not explosion, so it is safer. Implosion is like it reduces volume, and the coal or gas whatever is there, it aids the consumption, and even reduces the pollutants also. So when brown gas is consumed, this is much more cheaper and cleaner, and even it can reduce the fossil fuel consumption. So handling is not a problem. It is basically electrolyzer only, but without membrane, or say, even if it is there, but it's like you are not separating, you are not putting that much energy in separating the H2 and O2 fully. With even 1/10 energy, say 6 to 7 units of electricity, you can produce equivalent energy of 1 kg hydrogen. So this
it
is
is
the
something
advantage.
like
That is
stack or
why.
what, sir? Like you were discussing this
Pardon?
electrolyzer. So it is like a stack. The electrolyzer is like
Electrolyzer only, yeah, yeah. Just like electrolyzer, but slightly modified, like alkaline electrolyzer.
okay, sir. Thank you.
Yeah.
Is there any questions from any of the participants?
Hello, sir.
Yeah.
This is Dr. Suresh from Punjab Union College, Chandigarh.
Yeah.
Sir, this question is not from any slide. If you can share with me whether any metallic material has been developed for the storing hydrogen anywhere in the any country or not?
Yes, yes, yes. Actually, this is like much more cheaper and better way to store hydrogen. Already in India also, some development has happened, and one Canadian company is there. They are having and they are having football-like things, metal for storing hydrogen, solid hydrogen in metal hydride form, and in vehicles they are replacing cylinders, just swapping. So advantage is there, and yes, that is a ongoing research and quite successful in, as well as you don't need a lot of energy in compression, and you don't have to have like 750 bar or 350 bar pressurized cylinders. It is more like 5 bar or something like that, and it gets easily stored. I hope your question is addressed, Sureji.
Thank you, sir. Thank you so much,
Yeah.
sir.
Any other questions?
So can I ask a question apart from this hydrogen fuel and all things?
Let us see.
Actually, sir, I have a doubt about that. The recently in the newspaper, there is a misconfusion about that there is some kind of choking in the engines just because of ethanol blending in the petrol and gasoline, that we are using E20 fuels in our recently automobile sector. So there is a kind of an rumors has been raised up in the mass society, like this fuel is not suitable for the newly variant motorcycles or car, because after sometimes this fuel has to be seized the car engines and also the bike engines. So can you please elaborate if you think this is in your dimension?
Yeah, I can connect with you one to one. You can get my number from organizers. Uh, there are solutions also, but it's not that much a problem that has been created. Only some energy efficiency issue is there. So with the newer vehicles, it is not the problem. But yes, solutions are there even for older vehicles also. And things can be made from, like, ethanol is made from waste, and similarly those additives can be made from waste itself, and they can help in avoiding such situations or these rumors.
Sir, as recently in Germany using hydrogen powered railway system as in trial phase. So can we expect that India will also develop a kind of things that using green hydrogen as a fuel?
Yeah, India is India has already developed hydrogen powertrain, and the even the trains are the engine and everything is ready, and it is to be deployed at Sonipat to Jind section, and then you have seen some areas in hills like toy train and all. Then it is going to be deployed at those areas where steam is being used, or these cleaner areas. Uh, it is ready. Only thing is the electrolyzer which is producing hydrogen, which is being used to produce hydrogen, is having clearance still awaited from PISO. So the system can be ready. The train and engine is ready, but the this hydrogen production is having a clearance. So India is going to do it very fast. Your Sonipat to Jind train can run anytime after this.
Thank you so
It
much,
is
sir.
only recently, yesterday only, or day before yesterday, our minister Vaishnav had given this reply in Parliament.
Thank you so much,
Sir,
sir.
Buses are already running. Car I have shown you. trucks will run. Some tenders have come out for those.
May I ask one question, sir?
Yeah.
Yes, sir. I had put a question in chat section. Okay.
Okay.
So my question was regarding thermochemical conversion using
Yeah.
solar energy, CSP.
Right.
So you had mentioned a few technologies, and they
Mhm.
are working in India for some time. But can we say is it really commercialized, or still we are at demonstration or pilot scale?
Actually, in China, things have come up like I had even told about photo uh, catalytic water splitting for making
Yes.
hydrogen, that 200-ton plant. So this is having concentrated solar technology only for producing the heat to take that reaction, like I have shown that copper chloride cycle and the
Yes, sir.
other cycle. So there are catalysts which can uh, help in splitting water at various temperature. It is like it depends on the catalyst cycle as well as the technology or the materials which are used,
Right, sir.
or say phase change material if it is there, it can even do it at the same temperature. Like it can be like converting to heat, converting through heat to liquid state, then liquid to gas, gas to solid. And this new hydrogen is having that phase change material only. So it can convert split water to this hydrogen and oxygen at very low heat input.
Mm.
So, but this China one which I was telling, this is having a this concentrated solar for photocatalytic splitting. Then another company is Spark Hydrogen. They are also having concentrated solar. This is in Australia for
Okay.
splitting water. Then there are other companies which is not even thermochemical, electrochemical only.
Okay.
This is H2 Global or H2 Utility, and they have their this electrolyzer as solid oxide based electrolyzer, in which they have a coating for a cathode and anode. In between, the methane or any other blast furnace gas or off gases can flow. On the outer side, water is steam is transmitted, and through the electron flow itself, they can produce hydrogen. So,
Mm.
besides this heat, even without heat also, at nearly room temperature, they are able to produce hydrogen
Yes.
through that. They have run the pilot for about 2 years in a steel plant in Canada, and now they are going to test. Previously, they have used methane for converting to this hydrogen. Now they are testing their reactor for blast gases to convert to hydrogen. So there are lot many methods coming up. As the demand for green hydrogen shoots up, it will become cost effective, as it will require nil electricity at times or some heat, but not that much heat. So this is the advantage of these catalyst or thermochemical or electrochemical processes.
Yes. Thank you, sir.
Yeah.
This is a final call to all the participants. Is there any other questions? As the first session of this faculty development program has to be concluded soon, so I would like to request all the participants that is there any questions to our respected Rajan Vashni sir? Please may ask. No one? So
About the CSP, China has developed around 6 gigawatt in last 10 years, and around 4 5 gigawatts is in pipeline. And they have promoted CSP. Even in Tibet also they have put a plant, and their power policy says that this 2025 policy itself, we will promote CSP for firm heat and electricity. And the latest tender which has been awarded and the plant is under erection, one plant is under erection. They have awarded three plants of 350 megawatt and 10 to 14 hour storage. And the electricity cost is around converted to Indian rupees, around 6 rupees per unit.
That will be
So
much,
cost
they
effectiveness
are
is
much
there,
advanced.
24 by 7 electricity is there,
Yes,
and
right,
firm baseload power is there, not intermittent or
right.
say at the same time during the day when you have to curtail extra power or you have to store it somehow. And the major advantage is the least cost of energy overall system cost.
Right.
Like you don't have to put coal-based new plants for say meeting the peak load, which will be required say once or twice in a month or specific part of year, say during heat
May.
heat months, hot months
Yes,
when AC
June,
will
May.
require a lot of peak load.
Yes,
And moreover, peak shifting can be done. So base load and peak load will converge together, will tend to converge. So lot of transmission capacity will also have higher CUF. Like if you are installing transmission line just for transmitting the PV based power, it is used for 15% of the time, and that too at times it is intermittent, so you have to make it firm and other things. But if you have CSP also hybridized with PV, you can have 70-80% CUF, same transmission line. So cost gets reduced, per unit transmission cost gets reduced, and lot of new capacity gets avoided or deferred. Besides for India, a lot of pollution can also can be controlled. When we have most, say out of top 100 world cities in pollution, 90 are here in India itself. So it is like total win-win situation, controlling the pollution also, controlling the energy needs also, and extraction of coal and other things also, saving of jungles, transportation cost of coal. Here it is like it can run for 50 years and no load on minerals or earth for this, and use salvage value also. And it can help in like major advantages like you can do directly heating and cooling. So a lot of electricity requirement gets avoided.
Yeah, industrial heat can be taken care of to a large extent.
Yeah, industrial heat,
Yes,
industrial cooling also, building cooling
yes, yes.
also. Uh, so and now the data centers are coming up again, heat and cool both are there. So it can
That's
be
one more debatable thing, right?
yeah. So lot of ecosystem development can happen towards controlling the greenhouse gas emission. Yeah.
Thank you very much, sir.
I hope everyone has doubt has to be clear right now. Now it's time to thanks our chief guest as today's resource person, Mr. Rajan Washington sir, who has beautifully enlightened the various aspects of the green hydrogen and also tells us about the different aspects and different dimensions about the green hydrogen and various aspects for all the participants. Thank you so much, sir. On the behalf of Sri Satsai University of Technological and Medical Sciences, Sehore, once again, we are very thankful to you, sir, for sharing your valuable thoughts and valuable ideas to all the participants. And we hope that your valuable insights has been helping us a lot to all the participants in a futuristic technology. Thank you so much, sir. One thing I have
My
to
pleasure.
announce. Thank you, sir. One thing I have to announce to all the participants that feedback link has to be shared in your WhatsApp group, and I would like to request you all the participants that kindly share your feedback about Rajan Vashne sir because it is a valuable way of communication because without any feedback there is a no proper communication has to be developed. So this feedback form is the criteria of your attendance also. So I would like to say that please kindly share your valuable feedback about Rajan Vashne sir about this session, which has to be shared up the feedback form into the WhatsApp group. Thank you so much. Now, this is the time. Our next session speaker, the keynote speaker of the second session is Dr. Ashok G. Matani sir, has been joined up in this Zoom workplace meeting. We welcome you, sir. Welcome to Sri Satsai University of Technology and Medical Sciences in a virtual medium. And I hope so
Thanks.
that your valuable insights and thoughts has to be enlighten us in a different manner. As the in the previous session, we have learned a lot from about the hydrogen energy from Dr. Rajan Vashne sir. Now we are expecting that same thing has to be expected from you from your side, sir. Now, over to you, sir. Please carry forward from this session from here, sir. Welcome you once again, sir.
Good evening to all of you. Thanks for kind introduction, kind invitation for this Hotel FDP. The topic for today's expert lecture is hydrogen economy in sustainable goals framework. This PPTs are visible to you, sir? Now these are okay? Now these are moving on your screen.
Yes, sir, it is
Yes, sir.
visible. I think so.
And now this is grey hydrogen and this scientific. Yes.
Yes,
On
sir.
your screen it is
Slides are
visible.
changing as well. Yes, sir.
Yes,
Yes,
sir,
sir.
visible.
Very nice. Thank you. Okay. Yes. Now we go since it is first day and your theme of this FDP is related with hydrogen. Hence, I will go with slight fundamental or introductory part of hydrogen and then we progress one by one. How it is gaining its momentum, its importance, its significance in today's economy, energy scenario, and alternative renewable fuel also. Now, there are different types of hydrogen. This is now the most common classification today is through color spectrum, which categorizes hydrogen based on its production method and environmental impacts. So these color spectrum,
Please ask participants to mute themselves.
हाँ जो मन करे बना जो मन करे बना लो
Yes, should I
Yeah.
proceed?
Organizers can mute all participants. If participants are not attentive, organizers can, I think, mute all the participants.
Yes, in case anybody is having any question, you can ask me. Now, this classification is based on different colors, means according to the production method. The first one is just like we are having this rainbow color, same is its carbon footprint, and hence its classification are these different types of hydrogen are there. First one, the most popular is the green hydrogen. It is the cleanest form. It is produced by splitting water into hydrogen and oxygen using electrolyzer powered by renewable energy, wind, solar, or hydro. Then is blue hydrogen. This is produced from natural gas, usually methane, through steam methane reforming. This is the most popular method throughout world. This CO2 emitted is captured and stored underground using carbon capture and storage technology. Then gray hydrogen, this most common type today, like blue hydrogen, it is made from natural gas. Then brown and black hydrogen, then pink, purple, and red hydrogen. Then turquoise hydrogen means newest method that uses methane pyrolysis to split methane into hydrogen gas and solid carbon. Then white or gold hydrogen, this refers to naturally occurring hydrogen found in underground geological deposits. And yellow hydrogen means especially refers to hydrogen produced through electrolysis using solar power. Then different this scientific classification is means isotopes and states. Means in this protium means it is one H, whereas deuterium means H2, what we call this, and tritium means H3. This radioisotope with one proton and two neutrons. Then third, this split allotropes and physical states. Then what is the concept of hydrogen economy? Means why we call this hydrogen and economy? Because it is affecting, because its importance on today's economy, today's manufacturing, today's energy generation as a renewable energy, it is gaining its momentum, proving its importance. This hydrogen economy is a term for the role hydrogen as an energy carrier to competent electricity as part of long-term option to reduce emissions of greenhouse gases. The main aim is to reduce the emissions where cheaper and more energy efficient clean solutions are not available. Then what is the main of sustainable development? Because we are linking now here two different terms. First one is the hydrogen aspect, another is the sustainable goal or sustainable development. Means these sustainable goals, SDGs, are prescribed by, are defined by United Nations, and there are 17 sustainable development goals, and every country throughout world, those who are members of United Nations, almost all countries are members of United Nations, and they have to fulfill these goals. How they can accomplish these 17 goals, we go one by one, what that goal particular is and what is its significance too. And I am telling you, out of these 17, nearly 12 goals are fulfilled through university education. Means through education, technical education, or what we call it UGC and AICD education. Means out of 17, 12 goals we are fulfilling in university pattern, in academics. This is about creating the thriving world for everyone now and in the future by integrating people, means social aspect, in this health, education, gender equality, reducing inequality and peace. Planet means environmental protection, what we call that. It is covering climate action, clean water, sustainable ecosystems, and responsible consumption. Then prosperity means economic aspect, that is decent work, innovation, sustainable infrastructure, and poverty eradication. Means all these 17 goals are moving around this sub classification 3P, what we call that, people, planet, and prosperity. So these key action areas of SDGs are no poverty and zero hunger, good health and quality education, gender equality and clean water, affordable and clean energy, decent work and economic growth, industry, innovation, and infrastructure, reduce inequalities and sustainable cities. Nowadays, smart cities we are finding. Then responsible consumption and production, climate action, life below water, life on lands, and peace, justice, and strong partnerships. These are 17 goals, prominent areas, are key areas. These are 17 sustainable development goals, and here how green hydrogen is playing its significance. These are various goals and how this hydrogen is affecting its presence. This is through hydrogen production, then hydrogen transportation and end use of hydrogen. Means you see how these particular goals are means relevant to or affected by hydrogen. Now, this green hydrogen value chain presents for the meeting the SDG 17 SDGs. These production, there are total 17 sustainable goals in which 169 targets are prescribed. And through production, this green hydrogen production either directly or indirectly influences all 17 SDGs involving 57 of 169 targets. This production segment is responsible for influencing four targets in direct positive, 25 in indirect positive, and 7 in direct negative, and 21 in indirect negative way. This green hydrogen production can boost investments in renewable energy, thereby contributing to immediate progress of SDG 7, especially in developing countries. Means this is these 1 to 17 serial numbers are given, and according to that prescribed these definitions are there. Means for which that goal number and what are the specific areas covered under that. We have to fulfill that. Then in transportation, this green hydrogen transportation is directly or indirectly influencing 14 sustainable goals out of 17. Imagine involving 42 of 169 targets. This transportation segment influences four targets in direct positive, 21 in indirect positive, 3 in direct negative, and 14 in indirect negative fashion. This green hydrogen transportation can benefit the energy system by enabling seasonal storage and addressing the intermittency challenge of renewable energy SDG 7. Then end use. These green hydrogen end use either directly or indirectly influences 14 SDGs involving 50 of 169 targets. The end use influences 6 targets in direct positive, 26 in indirect positive, 6 in direct negative, and 12 in indirect negative minor. This green hydrogen end use and its use as feedback have the positive potential to enhance the agriculture productivity, decrease the reliance on food and fertilizer imports, enhance land quality, avoid soil degradation, and facilitate the adoption of local sustainable agriculture practices. Means these three goals are fulfilled through this SDG 20. Also, the use of green hydrogen can be optimal strategy by decarbonizing hard to abate emissions in certain sectors such as the steel industry and heavy transport. The fulfilling SDGs 7, 9, and 11. Green hydrogen may make the signal to climate change mitigation, but also improve air quality in cities. It is going beyond 900 AQI value. Imagine the situation. What can be just like poisonous gases we are inhaling in Delhi, those who are living in Delhi and NCR. It is very, very sensitive in these days, 3 months. AQI is going above 900 means the worst city. This green hydrogen can also directly and positively influence the residential sector by substituting fossil fuels in cooking and heating applications. Means SDG 7 is fulfilled. So these are different. Of course, these are the values which have been done by one research scholar, and they have means I have taken that reference. Ki how these SDGs are influenced with the utilization of green hydrogen. All the 17 goals, and they have taken these readings. So I have taken this part so that we should know okay, what is the significance or importance of green hydrogen in SDGs. Then why is hydrogen important for sustainability? Means 100% sustainable green hydrogen does not emit polluting gases either during combustion or during production. It is easy to store, which allows it to be used subsequently for other purposes and times other than after its production. This hydrogen economy is critical enabler for achieving the many of the SDGs, that is clean energy, climate action, and industrial innovation, SDG 9. This transition to green economy produced using renewable energy source offers significant opportunities to reduce emissions and foster the sustainable development. This target, of course, this is the target of our government of India. By next 5 years, means by the year 2030, this mission, green hydrogen mission, targets to development of green hydrogen production capacity of at least 5 million metric tons per annum with associated renewable energy capacity of additional 125 gigawatts over rupees 8 lakh crores in total investment. And then which country is leading in hydrogen? China. China is at the top. Of course, China is also one of the top leader of emitting CO2 emissions. Top five countries in which US, India, China, Japan, and Germany are these five countries which are the highly polluting countries in the world. Whereas Bhutan is the means zero carbon emission. Of course, it's a geographical area, its economy is very negligible. But it is the other side of the coin in which if we want progress, if we want prosperity, if we want comfort conditioning, standard of living, status living, then this is the negative other side of the coin is ki this is causing environmental degradation, CO2 emissions. Hence, China is taking lead in that so that they can minimize that carbon footprint. China has made the record. I have read one news yesterday night. Ki China has planted number of lakhs of trees in their city, in their country, so that they can minimize this carbon footprint. Means China is taking, even though China is working on this technology revolution, and considering the progress of China's technology revolution, probably within 1 year, China will be leading in technology revolution. Probably China will be trailing or means will be ahead of US and will be becoming within 1 year if this speed up innovations and technology revolution is as at the speed of this technology revolution today is in China. If this goes continue, probably it will be superseding US. Means imagine the progress of China. They are working on that. This is green hydrogen mission pillars. Then India targets these 5 metric million tons of green hydrogen. Hydrogen mobility pilots launched across 10 routes involving 37 fuel cells and hydrogen inter IC engines. Mission is to attract over 8 lakh crores in investment and reduce fossil fuel imports. Then, of course, there are slight disadvantages of hydrogen also. This includes its high cost, low energy density, and safety risk because hydrogen is explosive. Hence, this is the we have to keep this at low temperature and high pressure means we have to make some cryogenic conditions below 0 degree also at some places. Considering ambient air conditioners nowadays going temperature nearly 10 to 11 degree centigrade in central part of India, whereas northern it is chilling in Jammu and Kashmir, it is 2 or 3, and now it will be going to zero within 15 days. Amritsar will be the coolest, Srinagar will be coolest, 0 degree. Probably mercury will be dipping at zero in these northeast states. Hence, this transportation of hydrogen or storage of transport this hydrogen is one of the challenge, and we have to keep that as a cryogenic condition because of its explosiveness. It is highly flammability, necessitates strict safety measures and current like a widespread refueling infrastructure makes its practical use for many applications. Hence, we to take that much precaution. It is the only these are the drawbacks. Otherwise, hydrogen is totally means it is easily available. It can be produced easily with electrolyzers. Then its cost, of course, this cost is somewhat higher at present, but it is going to reduce considering its means widespread use and different countries how they are means implementing these hydrogen in their economy, and we go one by one how these different countries are achieving this. These hydrogen prices vary by type, just like gray, blue, and green, and region with gray hydrogen means fossil fuel based costing significant less means it is near 1.25 to $2.27 per kg. But producing emissions, while green hydrogen means renewable base currently costs $3 to $7 per kg, and it is aiming to reduce it to $1 to $2 per kg with incentives. In India, prices per industrial gas can range from 1200 to 3500 per cylinder, means approximately 1 kg, with green hydrogen production cost falling towards 260 to 310 per kg. These are key price factors and types. This gray hydrogen means cheapest from natural gas, costing 1.25 to 2.27 kg dollars per kg, but high emissions are there. Blue hydrogen, gray with carbon capture, it is 1.5 to 3 euro per kg, but more expensive. Then green hydrogen, it is from electrolysis with renewables currently $3 to $7 per kg, but it is going just like India. We are having this $3 per kg target. India has made that. These are Indian market snapshots. Means by this 3 months back, this data is there. Okay, industrial and laboratory gas, this was 1200 to 3500 per cylinder, depending on purity and supply. This green production, hydrogen production cost projected to drop to 260 to 310, means nearly 3 to $3.75 per kg. And auction bid is bid for green ammonia derived from hydrogen reached 55.75 rupees per kg. Future trends, major economies are pushing green hydrogen to reach $1 to $2, means 80 to 150 rupees per kg. Policies like India's National Hydrogen Mission aim to reduce costs through cheap renewables and incentives. Then what is the mileage of 1 kg hydrogen cars? These hydrogen cars mileage is typically around 250 to 300 kilometers per kg, similar to energy 2 gallon of gasoline, with some models like Toyota Mirai achieving over 100 kilometers per kg. And efficiency varying by different driving conditions, but ultra efficient prototypes have exceeded 2000 kilometer. Imagine, of course, these are prototypes, but at least we can achieve that. Means 2000 kilometers on 1 kg. Typical mileage is around 250 kilometers per kg. Of course, this depends, and Toyota Mirai is the best car which is showing its mileage with one regard showing 1360 kilometer on 5.65 kg cylinder, equivalent to 25 kilometers per kg, and general report suggesting 100 plus kilometers per kg. Means at least average if we consider 240 kilometers per kg in India, Toyota Mirai. Then there are key linkages between this hydrogen economy and SDGs. This primary mechanism through which the hydrogen economy supports the SDG is by providing the clean, versatile energy carrier that can decarbonize the hard to abate sectors like heavy industry, shipping, and aviation, which are difficult to electrify directly because, of course, new developments are going on in which now these aeroplanes are made from electric vehicles. Of course, these are under prototype. Experimental works is going on. Some models, some companies are working on this electric aeroplanes, but aviation and shipping and heavy industries mean just like steel and mining and cement industry. These are very carbon footprint is very means these are environmental degradation industries, and hence it is proving that we should minimize this carbon footprint with the help of these renewable energy sources so that we can fulfill our SDGs. Now, these are how these are fulfilled through hydrogen, SDG 7. Means it is affordable and clean energy. This provides means to store and transport surplus intermittent renewable energy. Its challenges are high production cost and lack of infrastructure. Then SDG 13 means climate action. This enables significant reduction of greenhouse gases emissions. Then SDG 9, industry innovation and infrastructure. This drives technological innovation, that is electrolyzers and fuel cells. SDG 6, clean
The
water and
presentation is not visible.
1 minute, I'm sharing again. Now it is coming.
Yes.
It is okay.
Yes, sir. Please continue.
Okay. Then SDG 6 is clean water and sanitation. SDG 8 is decent work and economic growth. SDG 12 is responsible consumption and production. Then what is policy and future outlook? This realizing the full potential of hydrogen economy in the SDG framework. Governments and international organizations are developing national hydrogen strategies to provide the clean roadmap for investment, research, and policy support. Initiatives like India's National Green Hydrogen Mission or the European Union's hydrogen strategy aim to scale up production and use of green hydrogen through financial incentives and regulatory frameworks. Even hydrogen train is now ready. Its coach have been made and this will be running commercially between Jind and Sonipat railway station in Northern Railway. This will be 92 kilometers distance. This will be running and this and the plans are going. This green hydrogen train will be running as commercial train, just like we are now using these different trains which are running on electric. These will be replaced. The government is working on this. Even hydrogen buses are also functioning and flying on even Leh and Ladakh also, and Delhi also. Probably in your city you might have seen this green, or you might be using that vehicle. Even green means car, hydrogen car, or hydrogen buses. So these are different uses of hydrogen gas. Means this is chemical properties of that left side, and its right side it is these are different applications of hydrogen. Then various uses of hydrogen are there. We go this global hydrogen consumption by different industries is breakup is there, in which we are finding petroleum refining it is 25%, methanol production 10%, ammonia production 55%, and remaining others are 10%. So these are HODs used in this, H2 is used in this food processing, fuel cell vehicles, heating and cooling, backup power, portable power, marine propulsion, aerospace, material processing, chemical production, and chemical production. These are different industrial and chemical manufacturing, in which this fertilizer production means hydrogen is primary ingredient in Haber-Bosch process used to synthesize ammonia, which is essential for nitrogen-based fertilizers, which we are seeing that since our wherever our memory goes, we have learned, we have read that ammonia is used as the fertilizer in agriculture. Then this is the process in which this Haber-Bosch process is called for producing this synthesizing ammonia. Then petroleum refining. These refineries use hydrogen for hydrocracking, means breaking down heavy oil molecules, and desulfification to remove sulfur impurities from gasoline and diesel. Gasoline means here petrol, what we call that. Then chemical feedstock. It is used to manufacture methanol, a building block for plastics and synthetic fuels. Food industry. Through hydrogenation, hydrogen converts liquid vegetable oil into solid fats. Then energy and power generation. This hydrogen acts as the clean energy carrier, that is energy storage. Surplus electricity from wind and solar powers can be stored as hydrogen via electrolysis. Fuel cells. These hydrogen fuel cells produce electricity by combining hydrogen with oxygen, emitting only water and heat as the byproducts. Backup and stationary power. Fuel cells provide reliable backup power. Grid blending means utility operators are blending hydrogen means up to 20% by volume into existing natural gas pipeline to reduce the carbon intensity. Then transportation and mobility, this heavy duty logistics. Companies also use hydrogen trucks, buses, and forklifts because of their rapid refueling times. Aerospace, NASA has used liquid hydrogen as rocket fuel since 1950s. By this year, commercial aviation companies like Airbus are actively testing hydrogen powered aircraft. Then maritime and railway. This Alstotam Corolla Island, this is the hydrogen powered train, and ships are emerging as zero emission alternatives for non electrified routes and global routes, which I was telling you between even government means Indian Railways have means they are successfully uh, made a prototype of this and they have obtained promising results. This whole rake is manufactured in integral coach factory at Chennai, and this is supplied to Jind Sonipat in Haryana in Northern Railway. Then specialized in emerging uses, that is steel making, then electronics, coolant, and nuclear isotopes. Then these are different methods of production of hydrogen. How this hydrogen is made. The most popular is steam methane reforming and water electrolysis. This steam methane reforming, this is the most widespread commercial method accounting for nearly 95% of US hydrogen. High temperature steam reacts with methane in the presence of catalyst to produce hydrogen and carbon dioxide. Partial oxidation, it is another method. Hydrocarbons react with limited amount of oxygen to produce syngas means hydrogen and carbon monoxide. Then methane pyrolysis is a new process that thermally splits methane into hydrogen and solid carbon so that CO2 emissions are reduced. Coal and biomass gasification. These feedstocks are reacted at high temperature with steam and oxygen to form syngas. Then second is electrolytic process means water splitting. In this electrolysis, use electricity to split water into hydrogen and oxygen. This alkaline electrolysis means the most mature and cost-effective commercial technology using liquid alkaline electrolytes. Then proton exchange membrane (PEM). It is known for rapid startup with high efficiency, making it ideal for fluctuating renewable energy. Then solid oxide electrolysis. It is high temperature method entering the market in 2025 this year and achieve efficiency above 80%. Third is solar driven and biological methods. This photo electrochemical PC water splitting. These uses specialized semiconductors to absorb sunlight and directly split water, eliminating the need for separate electrolyzer. Then photobiological process and fermentation. So these are different comparison of these different methods of hydrogen production. Five methods are there. So this is the comparison table of that methods. Actually, there are more than 6, 7, 8, 9, 10, 11 methods are there, but most popularly 5 methods are there. And in that first one is the SMR. These are this comparison table of different hydrogen production methods in which these are advantages and some drawbacks and efficiency and costs in dollars in per kg. So these are different processes, how this are happening. Now, this hydrogen spectrum means production methods. Should I share one video with you? What is going in different parts of the world, how they are implementing this hydrogen? I'm sharing that video. It will be more. This voice is coming to you? We bring you the latest in renewable energy. This video and voice is okay on your screen? Technologies. And don't forget, for more in-depth information and resources, visit our website and subscribe to our newsletter for the latest updates and exclusive audio is content. Okay? Welcome to ReneeEnergy.com, where we explore the latest developments in clean energy technologies.
Yes, sir. It's
Is it
okay.
okay? We're diving into the ambitious Are you able to see and listen? Na?
Yes, sir. Yes, sir.
As the
Okay,
world
thank you.
seeks sustainable alternatives to fossil fuels, green hydrogen has emerged as a critical component of the global energy transition. But what are the specific targets of these countries? And what does it take to turn these ambitions into reality? Let's start with the United Kingdom. The UK is making significant strides towards integrating hydrogen into its energy mix. Recently, a trial in Cumbria tested the blending of hydrogen into the national gas network, scaling up from a 2% blend to a 100% hydrogen mix. The success of this trial highlights the UK's potential to repurpose its existing gas infrastructure for use. The UK is also investing in green hydrogen production, with a 500 million pound pledge to support that. No country with green hydrogen. This minimize costs and improve trend. Require this technological advancement. Moving on to Japan, the country has positioned itself as a global leader in hydrogen technology. Japan's strategy is focused on importing green hydrogen to meet its domestic energy needs, given its limited renewable energy resources. The Japanese government has set ambitious targets, including the widespread deployment of hydrogen fuel cell vehicles and the establishment of a robust hydrogen supply chain. Japan's approach showcases the importance of international collaboration, as the country is forming partnerships with hydrogen exporting nations like Australia. This collaboration highlights the interconnected nature of the future hydrogen economy, where countries with abundant renewable resources can supply green hydrogen to those in need. Speaking of Australia, the country is leveraging its vast renewable energy resources to become a major exporter of green hydrogen. Australia's vision is to produce green hydrogen at scale for both domestic use and export, particularly to key markets like Japan and South Korea. The country is already developing large-scale projects, such as solar and wind farms dedicated to green hydrogen production. Australia's strategy underscores the economic opportunities presented by green hydrogen, as it aims to create jobs, stimulate regional development, and position itself as a global clean energy powerhouse. Finally, Germany is another key player in the global hydrogen economy. Germany's strategy is comprehensive, targeting the use of hydrogen across various sectors, including transportation, industry, and power generation. The country is focusing on building a robust hydrogen infrastructure, with plans to develop pipelines, storage facilities, and refueling stations. Germany is also leading the charge in hydrogen technology innovation, driving forward projects that integrate hydrogen into the European energy market. What's particularly noteworthy is Germany's emphasis on creating a regulatory framework that supports hydrogen adoption, ensuring that both public and private sectors can work together to meet climate goals. So, what does it take for these countries to achieve their green hydrogen goals? First, massive investments in infrastructure are required. From electrolyzers that produce hydrogen from water using renewable energy to storage and distribution systems, the physical infrastructure must be built or repurposed. This involves not just technological innovation, but also significant financial commitments from both governments and private investors. Second, international collaboration is essential. As seen with Japan and Australia, the hydrogen economy will be global, with countries exporting and importing hydrogen based on their natural resources and energy needs. This requires the establishment of international standards and trade agreements to facilitate the smooth exchange of hydrogen across borders. Third, regulatory frameworks need to be developed and implemented. Governments must create policies that incentivize the production and use of green hydrogen, such as subsidies, tax breaks, and carbon pricing. These regulations will help make green hydrogen more competitive with fossil fuels and encourage widespread adoption. Lastly, public awareness and acceptance play a crucial role. Educating the public about the benefits of green hydrogen and ensuring safety standards are met will be vital to gaining public trust and support. This includes addressing concerns about the flammability of hydrogen and the environmental impacts of its production and use. In conclusion, the global push for green hydrogen is not just about setting ambitious targets, it's about making strategic investments, fostering international cooperation, and creating an environment where innovation can thrive. The efforts of the UK, Japan, Germany, and Australia showcase the potential of green hydrogen to transform our energy systems and help us meet our climate goals. As these countries continue to advance their hydrogen agendas, they provide valuable lessons for others looking to join the green hydrogen revolution. If you're interested in learning more about green hydrogen and its role in the global energy transition, visit reneenergy.com. We offer a range of resources and courses that delve into the technologies and strategies driving the future of clean energy.
Whether you're a professional in the energy sector, a policymaker, or simply passionate about sustainability, our platform provides the insights you need to stay ahead in this rapidly evolving field. Thank you for watching. Don't forget to like, share, and subscribe to our channel for more updates on clean energy trends and innovations. Visit reneeenergy.com to start your journey towards a sustainable energy future today. Thank you.
1 minute, I'm sharing another video. Let us see. I'm trying to open this video. Otherwise, we go by PPTs.
Clean energy space, and that's green hydrogen. Well, India ignited its green hydrogen revolution in 2022
I'm sharing that video, please.
with a dedicated policy, sparkling a flurry of initiatives. The country has set a production target of 5 million metric
One minute, this I'm sharing that 1 minute.
But let's shift focus on the big theme, which is clean energy space, and that's green hydrogen. Well, India ignited its green hydrogen revolution in 2022 with a dedicated policy, sparkling a flurry of initiatives of green hydro energy by 2030. So what does India need to do to reach this target? Whether it will be able to meet this and how? Mika, which is at the sector closely, joins us with more details. Mika. So India has set many specific green hydrogen goals. Hydrogen is
Visible to you, no?
hydrogen
On your
is the
screen.
renewable electricity and could cause. But let's shift focus on the big theme, which is clean energy space, and that's green hydrogen. Well, India ignited its green hydrogen revolution in 2022 with a dedicated policy, sparkling a flurry of initiatives. The country India has set a production target of 5 million metric tons of green hydro energy by 2030. So what does India need to do to reach this target? Whether it will be able to meet this and how? Mika, which is track the sector closely, joins us with more details. Mika, take it over. So India has set many and specific green hydrogen goals. Green hydrogen is basically hydrogen produced by renewable electricity and could cause. But let's shift focus on the big theme, which is clean energy space, and that's green hydrogen. Well, India ignited its green hydrogen revolution in 2022 with a dedicated policy, sparkling a flurry of initiatives. The country India has set a production target of 5 million metric tons of green hydro energy by 2030. So what does India need to do to reach this target? Whether it will be able to meet this and how? Mika, which is track the sector closely, joins us with more details. Mika, take it over. So India has set many and specific green hydrogen goals. Green hydrogen is basically hydrogen produced by renewable electricity and could
Yes, it is visible on your screen, video and audio.
But let's shift focus on the big theme, which is clean energy space, and that's green hydrogen. Well, India ignited its green hydrogen revolution in 2022 with a dedicated policy, sparkling a flurry of initiatives. Currently, India has set a production target of 5 million metric tons of green hydro energy by 2030. So, what does India need to do to reach this target? Whether it will be able to meet this and how? Mika, which is track this sector closely, joins us with more details. Mika, take it over. So India has set many and specific green hydrogen goals. Green hydrogen is basically hydrogen produced by renewable electricity and could
There is some problem in video. Okay, I will go with our PPTs. Yes, I am sharing this. These PPTs are visible on your screen now. Now it is okay.
No, sir, nothing is visible.
1 minute, 1 minute, 1 minute. Again. Now it is coming. Now,
King.
okay, it will come. Let us hope. Now it is coming. Now, now displaying.
No, sir.
1 minute. I am leaving and again joining because it will be problem. Within seconds, I am again joining.
I think there is a technical glitch from their side. I hope so. He will be getting back soon. Uh, I am requesting you to all the participants that Ashok Matani sir trying to show you something on the slides. That's why he is having some technical glitch from their end. I hope so he will be get in touch very soon with you all. Kindly be patient. Here it is. Here is the slide which was to be shared. Welcome back, sir.
Yes.
Yes. Yes.
1 minute.
Yes.
Now, should I proceed?
Yes, sir. You should.
I am disconnecting one because I have made parallel. Hmm. Now, now slides are moving, no? Yes, should I proceed? These PPTs are visible now? Yes.
Send करें.
This PPT are visible now?
Ashokji, it is visible. Your bandwidth
Okay.
is slow.
Moving.
So if you can
1 minute.
mute your
I am.
camera and do it full
Yes, yes,
screen
yes. I am
and
doing.
just do it full screen.
Now it is okay.
अपना audio off कर.
Now,
I am able to see one slide which is having these methods use heat and chemical reaction first line like this.
now
But
this global
still it is
transition to
not full
hydrogen
screen.
economy. Okay, 1 minute. Again, I'm sharing.
So it's some other screen you have shared actually, or some other window you have shared.
No, this is from my on my screen. It is moving, but sharing. 1 minute. Again, I will share. Now this is coming. Global market dynamics and trade routes.
Still, it is not coming. It is showing a message you have started sharing or something like that.
Now it is moving. These key sectoral applications, challenges for implementation. This global hydrogen ecosystem. This is diagram is there.
No, no, no. It has not changed from the last screen.
1 minute. Again, I will show. Now moving.
No, you just unshare and reshare, maybe.
Now these key sectoral applications. It is moving on your screen,
Sir, the screen is coming.
but it is not moving.
No, sir, it's moving, but it's taking time only. And now, just wait. You don't have to give it in a full screen. We will see in this way also. You can continue with
No,
this way also.
this key recommendation to scale up hydrogen. It is coming on your screen.
Now it's coming what we know.
Now these slides are moving.
Yes.
Now this hydrogen production, hydrogen transport. I have
Yes.
made this
Yes.
picture.
Yes. Yes. Yes.
Okay. Now
Yes.
we should
Okay.
proceed. Okay. Thank you. Yes. Now these are different hydrogen production, different methods, then hydrogen transport and storage, different methods of storage and transport, and hydrogen use means various areas. So here we are finding these are different actually which are leading or which are having these innovative models in that this resource country it is Australia and right side it is utilizing country it is Japan. Okay, how this hydrogen production is effectively used in these just like utilizing country with the help of this storage, hydrogen storage and transports. with this liquefied hydrogen cargo ships are there, liquefied hydrogen containers are there, liquefied hydrogen storage tanks are also there, just like we are having petrol tanks. Then this is India's green hydrogen revolution. This screen is visible to you? Yes, this slide is visible.
Yes, sir, it's visible. It's utilizing country Japan. This is a picture view.
And after that, then again I have changed now. India's green hydrogen revolution.
Yes, sir.
It is moving now on your screen.
Yes.
Okay. Yes. So these are for India. These are different opportunities and slight challenges also. Now, opportunities for India's green revolution is renewable energy potential. We are having good sunlight, solar light, good wind energy resources, then job creation, export market is there, energy security and competitiveness. Then challenges are high production cost of electrolyzers, and dependence on imports. So these are, of course, these are slight. This production cost is 3.5 to 5.5 dollars per cost of electrolyzers are 500 to 1800 per kW dollar per kW. These are slight challenges also, limitations also, but definitely when this, of course, since this technology is new, nascent, and hence when this technology will be maturing and will be made, then its cost will be coming, and whatever drawbacks are there, this will be means overcome. Now, how this NTPC, National Thermal Power Corporation of India, it is under Government of India PSU, they have integrated this made green hydrogen project with monumental investment of 1.85 lakh crore rupees. It is located in Pudi, Madaka, Andhra Pradesh. Means it is near Visakhapatnam. This green hydrogen hub will encompass renewable energy generation, manufacturing, and critical infrastructure, placing India firmly on global map of green hydrogen pioneers. So these are India's green hydrogen revolution, in which key priorities for achieving these green hydrogen targets are means scaling renewable energy 100 to 125 gigawatt of additional renewable energy needed. Domestic manufacturing, stable local facilities for electrolyzers and hydrogen technologies. Policy regulatory framework, streamlined approvals and clear land use policies. Public-private collaboration, encourage partnerships to foster innovation, and leveraging R&D means develop cost-effective electrolyzers and storage solutions. Then this NTPC's project, that is game changer. This is spread on 1600 acres. Imagine the area, 1600 acres. NTPC's green hydrogen hub is designed to integrate renewable energy projects, electrolyzers, green chemical production, and supporting infrastructure like desalination plant and transmission corridor. With annual target of 1500 tons of green hydrogen and 750 tons of derivatives like green methanol and sustainable aviation fuel. This project is comprehensive approach to green hydrogen production. This is having this budget 1.85 lakh crore rupees in investment, creating jobs and fostering economic growth. This hub was inaugurated on 12th June this year by Honorable PM Sir. So India's National Green Hydrogen Mission launched in 2023. These produce 5, of course, 5 MMT its target, and it is creating 6 lakh jobs and reduce the fossil fuel imports by rupees 1 lakh crore. Telling you. Now, challenges on the horizon. This cost challenges is also one of them. Technology challenge is another component because electrolyte technology it is critical component. Moreover, it is cost intensive, requiring more amount of money. Means it's cost 500 to $1800 per kW capacity. Green hydrogen mission. Its name is NTPC's Integrated Green Hydrogen Project, located in AP. Investment 1.85 lakh crores area and annual production 1500 tons of green hydrogen, 7500 tons of derivatives means green methane sustainable aviation fuel. These at least we will be using this in airport. Opportunities for India also. This is one scheme is their site scheme. These funds are given for this with comprehensive this train is also on pilot project. It is successfully giving positive results. Means it will be now running on more mileage and more routes. This hydrogen train. Then this is budget allocation for Ministry of Power and Ministry of Renewable, New and Renewable Energy since last 10 years. Okay, imagine every year the government of India has increased its budget for improving or popularizing these means new and renewable energy sources. Then there are artificial intelligence in hydrogen economy means how AI is revolutionizing this hydrogen economy. We have seen that artificial intelligence is affecting our day-to-day life. When we wake up in the morning and we go to sleep in the night, every activity is affected by AI in our day-to-day working, in personal life, in our academic life, in our other different sectors where we are having daily work. Everything is now revolutionized by AI, and hence how this AI is used in these different optimizing green hydrogen production, storage and distribution through advanced analytics, predictive modeling, and real-time control, boosting efficiency, cutting costs, and enhancing the grid integration. Now, AI acts as the brain, creating the synergistic loop with hydrogen for sustainable energy future. These are key applications of AI in hydrogen, means in production optimization. These AI algorithms analyze renewable energy forecasts, that is solar and wind, and electrolyze data to dynamically adjust operations for maximum efficiency and lower cost for green hydrogen. Then catalyst discovery. These machine learning models accelerates the
Organizers,
identification.
can you please check the screen is not visible since very long?
1 minute, 1 minute. I'm now it is coming.
Yes, sir, sure.
Yes.
Now these key applications of AI in hydrogen I am displaying. It is now same on your screen. This is same screen or other. These key applications of AI in hydrogen.
Yes, it is now showing key applications of
Okay,
AI in
okay.
hydrogen.
Yes. Now in production optimization, then catalyst discovery, this machine learning and accelerates the identification of new, more efficient and durable materials for catalyst used in hydrogen generation. Then grid integration. AI-driven systems manage the integration of hydrogen into existing energy grids, balancing demand and supply, and predicting these imbalances, ensuring the stability. Then storage and distribution. These AI enhances the management of large-scale hydrogen storage, predicting leakage risk and optimizing conditions. Because this is also one of the challenge, just like we are having our LPG cylinders. This leakage is very means fatal, very sensitive, very means risk are prone to accidents. Hence, these AI algorithms identify the if there will be any leakages from this storage or from these tanks, then this will be predicting that leakage risk, optimizing conditions, and improve the safety. Then, for predictive maintenance, AI analyzes sensor data to predict equipment failure in electrolyzers and fuel cells, reducing downtime and operational expenses. Then demand forecasting. These AI models forecast hydrogen demands and optimize production schedules for meeting market needs efficiently. Then AI and robots are transforming the energy and transport sectors. Means in this AI, hydrogen synergy is there. Means powering AI's hunger means AI's massive energy demands, which our previous speaker was also means discussing with you, because now data centers which are running AI and other machine learning and heavy supercomputers and other their means algorithms and infrastructure facilities. Now, China, US, Japan, they are making these data centers in space. China has developed technology in which now even US also they have made data centers under sea. The new developments is going on, which I have read last week. These data centers are being made in space because these require huge power consumption plus air conditioning, which is causing environmental degradation plus also energy shortage. Hence, these new platforms are identified for data generation, setting up these data centers in space, in underground, under sea. The same will be required here because AI's massive energy demands, particularly for training large models, can be met by green hydrogen, creating self-enforcing loop where hydrogen powers AI and AI optimizes hydrogen. Decarbonization. Green hydrogen produced with renewable energy provides a stable, dispatchable power source for AI infrastructure. Enhanced decision making. This AI provides data-driven insights for policy, investment, and technological development. Of course, these are some challenges in AI implementation. So these are latest real life examples of hydrogen. This fertilizer production, petroleum refining, steel manufacturing. So these are different case studies where these are used. This steel manufacturing hydrogen is increasing usage, reducing agent to replace coal in steel production. This is in Sweden. They started construction of world's first large-scale 100% hydrogen-based direct reduced iron plant in 2023. Then in chemical manufacturing, then this this Mars company, we have seen that Mars containers on the sports even goods trains containers when we are waiting for a railway station for our train, and in case this any goods train is crossing, then you might have seen that marks containers. Means these containers are taken from these seaports or harbors, and from there these are transported to different cities. This Maersk is the leading company. This launched in 2003 is the first container ship to run on methanol fuel derived from hydrogen and captured carbon. Then passenger and heavy rail. This Korodia Island, this is world's first passenger train. Powered by hydrogen fuel cell, traveled 1175 kilometer without repelling in September. Means 4 years, 3 years back, this train was running. Then heavy machinery and trucks. This UK-based JCB has developed hydrogen combustion engines for backhoe loaders and excavators, and had recently installed these engines in 7.5-ton Mercedes trucks. These public transit, these many cities have deployed hydrogen bus fleets. This Aberdeen, Scotland, operates hydrogen double-decker bus, while US has roughly 60 fueling stations, primarily in California. These personal vehicles, comfortable models like Toyota Mirai, Hyundai Saxo, and BMW iX5. These are run green hydrogen. Then energy storage and power generation. This grid stability and microgrids. In northeast Germany, Uniper launched inaugurated this hydrogen storage pilot on Salt Cavern in August 2022 to store large volumes for later use. In India, NTPC also operates green hydrogen microgrids at Dadri and Greater Noida. Data center backup. In 2020, Microsoft successfully tested running a data center server for 48 hours using only hydrogen fuel cell backup generators. Power plant blending. This mountain power plant in Utah is being retrofitted to run on 30% hydrogen, 70% natural gas mix, with goal of 100% hydrogen by 2045. Then global mega projects and hubs. This NEOM green hydrogen project, it is in Saudi Arabia. It is $8.4 billion joint venture aimed at producing 600 tons of green hydrogen per day. Imagine the capacity. 600 tons of green hydrogen per day by next year, which will be converted into green ammonia for exports. For India, this green hydrogen mission launched in 2023, it is targeting 5 million metric tons of green hydrogen production per year. Imagine per year and per day. This capacity. This is Saudi Arabia's the biggest in the world. 600 tons per day, whereas we are having 5. Ulsan Green Hydrogen Town with extensive pipelines for distribution. Germany's H2 Exil project converted salt converts for hydrogen storage. These are different hydrogen trends in 2025. Means this year, new trends related with hydrogen applications are there. First one is hydrogen innovation and trends. These slides are visible to you, na? These
Sir,
are moving
physically
on your
not
screen.
visible.
1 minute, one. Again, I'm sharing. Now it is coming.
No, sir.
Now,
No, sir.
No, sir. No, sir.
now,
No, no, sir.
this from my side it is showing, but now it is okay.
No, sir. No visible.
1 minute. I am again opening in other this browser. No, no, I am trying that so that it will function in another browser. Probably this can be the problem here. Browser. Let us see if it will function in that. I'm trying that. It will come.
Yes, sir. Visible.
Now it is okay, na?
Yes, sir. Yes, sir.
Okay, okay. Then we can proceed in that way. Now, this hydrogen innovations and trends. This renewable hydrogen and carbon capture will be major influence on all other trends because of interaction with clean hydrogen production. Biomass gasification along with X2 hydrogen to X technologies provides another sustainable method for creating hydrogen. This is different top hydrogen trends. Hydrogen fuel cells now use renewable and hydrogen advanced electrolysis, X to hydrogen to X, hydrogen carriers, carbon capture, utilization storage, hydrogen distribution, hydrogen propulsion. These first hydrogen fuel cells. These fuel cells find applications in marine, land, and aviation operations, including ships, trains, planes, and drones, cars, trucks, and buses. These heavy industrial vehicles become primary focus point in hydrogen economy. Businesses are increasing adopting these hydrogen fuel cells to reduce these carbon footprints. Second is H2X designs, means hydrogen fuel cells vehicles. These Australian startup H2X. These designs and develops hydrogen fuel cell powered vehicles. These require only 5 minutes for refilling and also provide longer range per refill than battery operated vehicles. Yes, these are visible on your screen.
Yes, sir.
Yes, sir.
PPTs. Okay, thank you. Yes, yes. These are BWR. This US-based startup, that is one name of that, BWR Innovations, provides portable hydrogen fuel cell solutions. The sole source SFC 110 fuel cell generator is BWR Innovations fuel cell powered sanitization product. It is portable fuel cell generator and heater that inactivates a variety of biological contaminants. Then renewable hydrogen. Then high seas energy leverages offshore wind turbine platforms for hydrogen production. This is US-based startup. This high seas energy develops offshore wind turbines to power electrolyzers. This name of platform is this high seas free floating offshore wind turbine platform. This provides low cost, low mass, and stable platform for turbines up to 40 megawatts. Imagine these 40 megawatts, very good capacity in platforms, means in wind energy. This is very huge amount of power generation, 40 megawatts. This H2 Gen develops solar powered hydrogen. This is German startup. This utilizes solar energy to produce green hydrogen. This startup project Sunrise powers 30 megawatt electrolysis plant using green electricity via solar panels. Then advanced electrolysis. This This is name of that company, that US-based startup. Alchemer offers AEM electrolyzers to produce hydrogen. It is AI chemi technology allows for low electrolyte degradation. Then H2B2 engineers large-scale electrolyzers. Then X to hydrogen to X. Then Electrogravix develops the parallel mass transfer electric generator. Then hydrogen carriers, just like we are having these trucks, carriage trucks and trains, same transporting this hydrogen will be through carriers, means with big storage capacity tanks on the roads, or through marine, or through rail, or through roads. These metal hydrides such as magnesium hydrides have the capacity to chemically store hydrogen in their metallic lattice. Then these H2 site facilities and on-site hydrogen production. This is Spain-based startup which offers on-site hydrogen production. This Hydrogen First provide, this is name of that Polish for startup, Hydrogen First name of company, that develops flat composite overhead pressure vessels designed for hydrogen storage. This carbon capture utilization storage, this technology into hydrogen production reduce environmental impact. These technologies associated with blue hydrogen are integrated into large scale production. Then sustain leverages. This is name of that company, US startup Sustain. This provides blue hydrogen using CCUS technologies. This even Horizon Energy uses CCS to synthesize blue hydrogen and blue ammonia. This is startup. These produce this blue hydrogen. Arctic blue hydrogen is the startup's product. Then hydrogen distribution through storage containers. Handling this through then found energy. This is name of that company. Develops hydrogen energy distribution system. This is startup found energy. This develop technology that use metallic aluminum to produce hydrogen and demand for energy transport. Then Hiringa Energy establishes hydrogen refueling network. This is New Zealand-based company. It accelerates the hydrogen economy by developing hydrogen refueling network across New Zealand. Then hydrogen liquefaction and compression. Then Beyond Scroll, this is Swiss company. This builds oil-free scroll compressors to make green hydrogen production more efficient and cost-effective. Then Cyrus, this is Greek startup. This designs metal hydride for hydrogen compressors. Then combined heat and power. Then Turbotech designs hydrogen gas turbines. This is Belgian company. This develops hydrogen gas turbines for CHP. This startup hydrogen fuel gas turbine Turbotech HYTG 550. It is name of that. It is designed as a marine propulsion and generator units. Then Protium Green Solutions develops hydrogen-based industrial heating solutions. This is UK-based company. It is producing green hydrogen energy services, implementing CHP solutions for hydrogen-based industrial heating. Then hydrogen propulsion. Then this Turbotech develops hydrogen-powered turbo generators. This is French company. Turbotech. It designs hybrid electric propulsion systems for aeroplanes and electric vertical takeoffs and landing eVTOL vehicles. Then Ursa Major Technologies design liquid hydrogen propulsion system. This is US based. This Samus is the startup's 50,000 lbf liquid hydrogen engine. This discover all hydrogen economy trends with you so that it will be means I am closing this so that I can share video because two both parallel are not functioning. I have to close one, hence I am now starting. 1 minute, I am starting one video is with me. 5 minutes video is there. We will see that. I am opening that video. 1 minute, I'm opening it.
And that's green hydrogen. India ignited its green hydrogen revolution in 2022 with a dedicated policy, sparkling a flurry of initiatives. Currently, India has set a production target of 5 million metric tons of green hydro energy by 2030. So, what does India need to do to reach this target? Whether it will be able to meet this and how?
Now it is okay on your screen.
Sector closely joins us with more details. Nika, take it over. So India has set many and specific green hydrogen goals. Green hydrogen is basically hydrogen produced by renewable electricity and could
This is 3 minutes video.
theme, which is clean energy space, and that's green hydrogen. Well, India ignited its green hydrogen revolution in 2022 with a dedicated policy, sparkling a flurry of initiatives. Currently, India has set a production target of 5 million metric tons of green hydro energy by 2030. So, what does India need to do to reach this target? Whether it will be able to meet this and how? Nika, which is track this sector closely, many and specific green hydrogen goals. Green hydrogen is basically hydrogen produced by renewable electricity and could
This video is not running properly because
let's
this
shift
again it
focus on the
is
big theme,
stopping.
which is clean energy space, and that's great.
At same point it is. 1 minute, I'm sharing PPT now.
Sure, sir.
Video was having some problem. That video was not functioning, hence I hope not sharing that. Again, this was stopping at same point. I'm on another office. I'm coming. Yes, sir. 1 minute, I'm opening. Let us see if it is functioning properly. Because that video is showing means when we are seeing these through world level developments in video, this highlight how they are functioning in different advanced countries. Of course, since in India it is totally nascent technology, let us see one sharing opening that video so that we can see what is going on around the world. Okay, otherwise share PPTs.
Sustainability. Our channel is dedicated to bringing you the latest innovations and insights in green energy, including cutting-edge development in hydrogen. Whether you're a sustainability veteran or just beginning your journey, we have something for everyone. Join us on this channel to explore inspiring energy, sustainability, and cutting-edge technologies. And don't forget, for more in-depth information and resources,
Now this
visit our
video is
website
visible
and
to you,
subscribe
sir?
to our newsletter
On
for
your
the
screen it
latest
is coming?
updates and exclusive content.
Yes, sir. Yes, sir.
Hello, and welcome to ReneeEnergy.com. Today's
Okay.
video, we'll
Let
be
us see.
exploring the exciting intersection of the circular economy
Because
and green
this shows
hydrogen,
what
and
is
how the
going
new
on
ISO
in different
standards are
parts of
shaping the
world.
future of clean energy projects. As the world moves towards sustainability, industries are shifting from traditional linear economic models toward a more circular one. This shift emphasizes reducing waste, maximizing resource use, and designing products with longer life cycles. A crucial part of this transition is the adoption of green hydrogen, a clean energy source produced using renewable resources like wind and solar. Green hydrogen offers a solution to decarbonizing hard to electrify sectors such as heavy industry, transportation, and energy storage. Through the electrolysis process, which separates water into hydrogen and oxygen using electricity from renewable sources, green hydrogen is produced without carbon emissions. This makes it an essential part of the global effort to reduce greenhouse gases. But the move toward green hydrogen is not This is where the new ISO 59000 family of standards, released in May 2024, plays a pivotal role. These standards, ISO 59004, ISO 59010, and ISO 59020, provide organizations with the guidelines and tools they need to integrate circular economy practices into their operations, including green hydrogen projects. Today, we'll break down what these standards mean for green hydrogen and why they are critical to the future of sustainable energy. ISO 59004 to 2024 establishes the vocabulary, principles, and framework for the circular economy. It lays out 6 key principles that help companies transition to more sustainable models, with systems thinking being one of the most important. For green hydrogen, systems thinking involves looking at the entire hydrogen value chain, from energy generation to hydrogen production, storage, distribution, and eventual use in sectors such as transportation or heavy industry. This approach allows businesses to evaluate the environmental, social, and economic
Sorry
impacts at
to
each
interrupt
stage
you.
of production,
I would like to
ensuring that
request to all
resources
the
are used efficiently
participants to
and that
kindly
waste is minimized. For example, systems thinking can help hydrogen producers manage water use and help them ensure that renewable energy inputs are maximized,
Yes,
thereby
any
reducing the environmental
questions,
footprint of
welcome.
production
Should I stop that video?
beyond environmental impacts.
Yes, sir. Yes, sir.
Thinking also helps businesses consider the social and
Yes.
Sorry to interrupt you,
Yes,
sir.
any
Actually,
queries,
the
welcome.
time is 9:30
ensuring
p.m.
that green
So
hydrogen benefits
Yes,
as
by
many
9
can
stakeholders.
so that
close.
the other
Another principle of ISO
This 3 minutes video is
59004 is
there.
value
I will close
creation.
that as soon.
Yes, sir.
Such
We
Yes,
as
by
want that
9:30 we
we have to
close.
conclude the session till 9:30, sir.
Yes,
as
yes,
well as
yes.
designing infrastructure that can
Now
ensure
I
that
would
cost
like to
efficiency
say something to all the participants. Kindly open your camera so that we can take a proper screenshot of all this recording so that
production relies on
the
renewable
proper
resources.
video of your
Water.
screenshot has to be
So
shared with
59004
AICT again. So I would like to request to all of the participants
ensuring
kindly
that they are energy sustainable.
reopen your
This
camera
smart grid
so that we can
that
take a proper
optimize the use of
screenshot.
renewable energy during hydrogen production or advanced water recycling techniques to minimize water consumption in the electrolysis process. While ISO 59004 outlines the guiding principles, ISO 59010 to 2024 focuses on helping
Thank
businesses
you so
implement
much,
circular business
everyone.
Yes,
models.
suppose any questions or any suggestions,
ISO
welcome.
59010 introduces
yeah,
Because I have to
participant, you can
conclude
ask
at
any
9:30.
question related to that
what's the model as
session.
product as a service.
And sir is eagerly waiting for you guys. So please, you can ask anything related to green hydrogen. Whatever you have any question.
Or they want to share something new, welcome also. No problem in it.
Yeah,
Some
sure,
of
sure, sir.
participants might be knowing better than this. We should encourage them and they will share that. Because it is totally new, emerging, nascent technology. Or my email and mobile is with you. You will be sharing this to participants also. In case they are having any doubt or suggestion, welcome in that, sir. Yes, any suggestions or any questions or any something new you want to share, welcome.
Does anyone have any question, any kind of query related to the topic? They can ask. It's just an open forum like a discussion where you can exchange your thoughts and ideas or ask your queries. So is that clear to everyone that can we conclude this session? Anyone can say that?
Yeah, include it, sir.
So here we can conclude the session for the first day of this today's FDP program. Thank you so much, Dr. Ashok Matani, sir, for sharing our valuable insight to all the participants. I hope so that the all the participants, those who are joining in this Zoom workplace, has to be get a valuable insight from your side. Unfortunately, due to the technical glitch, uh, some videos and slides are not to be visible to all the participants, but we hope so that after sharing these kind of slides to into the groups, they can get the whole idea and whole thoughts whatever you want to share to all the participants. Now once again, at last, I would like to say something to all the participants. The feedback form has to be shared in the group, in the WhatsApp group, so you can fill up these feedback forms so that your attendance has to be recorded in the offline mode. So I would like to request once again to all of you, kindly share your feedback about this session and about this FDP. There are some few questions in this feedback form, so that answer these valuable question, answer these small questions, and your registration and your attendance has to be recorded in a virtual form. Thank you so much. Thank you, Ashok Matani sir, for joining us and sharing your valuable thoughts. We are very obliged from your side that we got a valuable information from your side. And also, thanks to all the participants who get their valuable time in the late night this FDP session, and all the participants those who are not joining, I would like to request that they will come and join this kind of session in the next day. Tomorrow we will meet at the same time at the 6 o'clock on the day two. And once again, thanks to Honorable Vice Chancellor of our university and all the technical team, Dr. Yogen Tyagi sir, Himanshu Jaiswal sir, and at last, thanks to Dr. Santosh sir, and also our research director, Dr. Mohit Gangwar sir, who is continuously stay joined with us and at last, also thanks to the coordinator of this program, Dr. Sachin Baraskar sir, and co-coordinator Mr. Manoj Kumar Ganwani sir. And at last, good night to everyone. Your host, Desh Deepak, Assistant Professor from Aeronautical Department. See you soon. Good night to everyone. Thank you so much.
Yes.